this morning is the naming, the unveiling of the module behind us. I feel a little bit like the Queen. All I need is a bottle of champagne. What I wanted to do was simply let everybody know that what we have here is the European Space Agency's Columbus.
Good morning to you all. My name is Jim Kennedy. I'm the director at the Kennedy Space Center, and on behalf of the 15,000 men and women that call KSC home, I want to welcome you to this spectacular event today. I recall 3 years ago this month that we stood a little bit farther down in the high bay to welcome the Japanese experiment module and the node, and what a special event that was, one that gives us pride in the fact that we are all a part of exploring space together. This is another significant milestone that we're going to commemorate today. Indeed, this milestone started many years ago, but I was impressed when I read that when the Columbus Laboratory left Bremen, Germany on the 28th, that there were 1,000 men and women from the media to document that historic event, a big historic event for our European friends and indeed all of the international partners. Significant for Europe, significant for all people. No one country does this alone. We do it together as international partners, exploring space for the good of all mankind.
We have a unique opportunity today to look at some really amazing hardware that's been put together by a truly international team. You look at the hardware and just think of the many thousands of hours that our European colleagues have put into this module from the beginning design until where it is today. And it's a tremendous accomplishment to the amount of work that they put into this module. So go out in your backyard tonight, look up into the sky, you'll see that space station star come overhead, and then imagine you were here in this building at the Kennedy Space Center seeing the other half of the space station. This will not be an easy task for our team. This will be the largest challenge we've ever done. The assembly that comes in front of us will be a tremendous challenge. It will be risky, but it is worth it. You can ask any of our workers in any country throughout the world that have worked on space station, and they will gladly tell you why they work, why they address that challenge every day. And this is your chance to look at this hardware and internalize and think about the moment of what you see here.
And from here at KSC, Columbus will make next year the last but the most important part of its very long journey. It started a long time ago in the workstations and the workbenches in Europe, and here it is today, and it's looking forward, as we are, for it to take its place with the International Space Station. And now, 10 years on, the construction of Columbus is complete, and we stand here in front of our future European house in space. A European house, yes, but houses are built to live in, not just to look at. Why did we do Columbus? Why are we participating in the space station? It's a question that we rather frequently get asked, and there are lots of answers, ranging from the noble aim to always seek for the unknown, to acquire the expertise that one gains from leading edge technology and help our industry to become even more competitive, to exploit the broad and deep scientific utilization potential of a vehicle like this, to obtain experience of operating large infrastructure, and to prepare the stepping stones for the further exploration of the solar system. And on it goes. I think it can all be summarized in just one phrase. We made Columbus, and we participate in the space station so that tomorrow we'll find the answers to questions that we don't even know the questions themselves today. And I say good luck to Columbus and to success to all the teams that are going to work there.
This is a unique place in the world. I feel very fortunate to be able to be a part of such an amazing program, and I truly believe that we are serving a higher cause by our work in extending the human's presence in space. We're first going to complete some post-delivery verification here in the Space Station Processing Facility, and then we're going to get Columbus ready to go in the vacuum chamber over in the ONC building. And that's the same vacuum chamber that's got a rich history both in the Apollo program and the Space Station program. That same vacuum chamber was used for the Apollo command modules and the lunar service modules. More recently, it was used to test the Space Station laboratory that's on orbit today, as well as the airlock that's on orbit today, as well as the node that's right behind Columbus. We are proud to be partners with ESA and are excited to help you to continue your launch campaign here at the Kennedy Space Center. You are our guests here in Florida. I'm confident that you'll be pleased with our efforts as your hosts. In fact, I think you will come to look at these NASA and Boeing folks as really part of your team.
Columbus is one of the most important European contributions to the International Space Station. In the same way as other ISS elements, Columbus will be taken out of the shuttle's cargo bay with a robotic arm. It will then be attached to another European-built element, the Node 2.
As you can see, this is a laboratory. It's a pressurized laboratory. It's about 5 meters long, 4 meter diameter, and it accommodates what you can see here, scientific experiments. Here you have 4 racks, and it can accommodate up to 16 racks of scientific experiments. And it allows 3 crew members to operate this module and to generate science in a short-sleeve environment. In addition to that, there is an external platform outside that can accommodate up to 4 facilities. We are going to launch 2 of them, Solar and UTEF, and they accommodate outside on the so-called EPF.
Each rack is a laboratory in its own right for research in different disciplines in space. The European Draw Rack is designed for scientific experiments in a variety of subjects in all of its 7 interchangeable drawers. The European Physiology modules are dedicated to experiments to better understand the workings of the human body. Biolab is designed for biological research in space, investigating the role that microgravity plays on all functions of an organism. Together with the EPM, experiments in medical and pharmaceutical research will be performed, aimed at the application of improving health on Earth. The Fluid Science Laboratory allows research into the dynamics of fluids. The first experiment to be performed might help to better understand the flow of the fluids in the outer core of Earth. External experiment facilities can be mounted outside Columbus. 2 of these will be launched together with Columbus this year. The first, called UTEF, includes several technology demonstration experiments, including exposure to space of new materials. The other, Solar, measures the radiation from the sun to understand its influence on Earth's atmosphere and its climate. The internal facilities are already installed in Columbus, so that the experiments can start immediately after it has arrived at the ISS. On board, the ISS ESA astronaut Leopold Earts will support the activation and checkout of Columbus and its experiment facilities.
Well, the scope of this Columbus mission is, this is the first mission for Columbus, so we are going to bring it up in the shuttle and then unload it from the payload bay of the shuttle and attach it to the station. And then we'll make all the connections and activate the module. And then there will be, during the rest of the flight, which is a long duration flight for me, a lot of commissioning tasks. Means making sure that all the systems, all the scientific facilities are working correctly.
While Leopold Earts and his crewmates will conduct experiments in Columbus, the researchers on ground can take part in their investigations as if they too were on board, thanks to advanced communication technology and imaging systems. The experiments carried out in Columbus will be scheduled and supervised from the Columbus Control Center at Oberpfaffenhofen in Germany. Through this control center, researchers all over Europe can receive the results of their experiments in real time. Former ESA astronaut Reinhold Ewald is one of the ESA mission directors for the Columbus operations.
The Columbus Control Center will come into action soon. We are simulating right now the mission of the Columbus Laboratory. The Columbus Laboratory will be attached to the International Space Station, and then the Columbus Control Center will join the sequence of control centers all over the world. Houston, Moscow, and Munich will be called in order to control the systems of the Columbus Laboratory.
Although Columbus is smaller in length than the other modules of the ISS, thanks to the ingenuity of the European engineers that have designed Columbus, it offers the same number of racks for research as the American and Japanese laboratories. And, by being smaller, all the initial internal and external payloads are launched together with the module, thereby saving extra launches, time and expense. Once in place, Columbus will begin to bear the fruits of Europe's investment in the ISS program. Its scientific results will give us a greater understanding of life on Earth and further the development of technology. And it will undoubtedly make every European feel proud that their space agency, ESA, is a part of the biggest international research project ever undertaken.
When Christopher Columbus returned to Spain to inform the monarchy of his discovery of the New World, he could not have possibly imagined the profound effect his journey would have on the future. Nations would flourish in the wake of this voyage, spawning new ideas, a pioneering spirit, and an ingenuity that has spread new technologies, medicines, and economic growth throughout the world. Centuries later, humanity would reach out to the heavens and truly touch new worlds. Our lives today were shaped by the actions of those early explorers, just as the lives of future generations will be shaped by today's pioneers who push the boundaries of our capabilities and knowledge. With the launch of STS-122 and its multinational crew of 7 astronauts, the International Space Station will grow in both volume and scientific capability. This flight of the Shuttle Atlantis to the station will be a major milestone in the assembly of the outpost, marking the beginning of a new era in international spaceflight and space science. Previous shuttle missions have paved the way for Atlantis' flight. Over the past year and a half, astronauts have installed and repaired solar arrays to increase the power of the station, spread radiators to boost its cooling, and added a connecting module that will serve as a pathway to new laboratories. The highlight of the mission will be the delivery and installation of the European Space Agency's Columbus Laboratory, the first scientific expansion of the orbiting complex since the U.S. Destiny Lab was launched in 2001. The crew of STS-122 is a mix of seasoned veterans and first-time space travelers. Leading the mission will be veteran astronaut Steve Frick, a Pennsylvania native who served as the pilot for Station Assembly mission STS-110. Navy Commander and Georgia Tech alumnus Alan Poindexter will make his first voyage into space as the pilot of Atlantis. During the mission spacewalks, he will serve as the in-cabin spacewalk coordinator and help with operations of the shuttle and station robotics. Mission specialist Leland Melvin, another first-time flyer, will be among those who operate the space station robotic arm during critical assembly tasks once Atlantis reaches the station. Melvin will also control the shuttle robotic arm as it is used to inspect Atlantis' heat shield. Mission specialist Rex Walheim, a veteran spacewalker and Frick's fellow crew member on STS-110, rejoins him on this flight. The former NASA flight controller is the lead spacewalker and will take part in all spacewalks planned for Atlantis' flight. Oregon native Stan Love is an avid outdoorsman who will be making his first flight on STS-122. Love will conduct the third spacewalk of the mission with Walheim and will operate both the shuttle and space station robotic arms during the flight. The crew of Atlantis includes 2 veteran astronauts from the European Space Agency, Hans Schlegel and Leopold Eyharts. Schlegel will conduct the first 2 spacewalks of the flight with Walheim, hooking up the Columbus lab. IHARTS will oversee the activation of Columbus, working in concert with ground controllers, and will remain on the station to continue the setup and begin research in Columbus as a long-duration crew member. Atlantis will bring home astronaut Dan Tani, who has been a resident on the station since October. The Columbus Laboratory is 23 feet long and 15 feet in diameter. Its facilities offer tremendous new scientific capabilities for the station and will be the center of the European Space Agency's activities on the complex.
Columbus is a lot of laboratory space. Space station up till now has been a construction project. There has been some science done on board, but as hard as science is to do, it's even tougher in a construction zone. And Columbus will add some much needed lab space that's dedicated to research and not having to do double duty as operating the main station and being a transfer corridor for lots and lots of people and things.
And not only do we get to bring it up and install it on the space station, but we get to go inside and work in it afterwards and see the dramatic change to the space station with the addition of this new volume.
Well, it's kind of like adding a whole new member to the team, because now the Europeans will have their own laboratory module. They can do their own experiments, and they can let their research dictate what they want to do, and they will be able to do it with a beautiful state-of-the-art laboratory module on board the space station exposed to zero gravity and do all the kind of research that they want to do.
3 spacewalks are planned for the mission as the astronauts install Columbus and continue outfitting the station. During the mission's first spacewalk, mission specialists Rex Walheim and European astronaut Hans Schlegel will attach a grapple fixture or handle that the robotic arm will use to lift Columbus up and out of the cargo bay. Columbus is such a large addition to the station that there was not room in the shuttle's cargo bay to launch the science facility with the grapple fixture attached. Space Station robotic arm operators Stan Love and Leland Melvin will capture the fixture with the station's Canadarm2, lift Columbus from the payload bay, and attach it to the station. Once Columbus is installed, the astronauts will run several tests to make sure the module is sealed and pressurized before it is opened for the first time the following day.
I think once we all go in, Leo and Hans will go in first and make sure everything's okay, no cobwebs in there or anything, but it's going to be very exciting and a testament to the teamwork from all of the nations that have put this vehicle together. It's just going to be very, very, very fun.
NASA's ground control will be in charge for some of the initial activation of Columbus's systems, but once the laboratory's computers are up and running, the European Space Agency's all-new Columbus Control Center in Germany will take over. Walheim and Schlegel will venture out again for the mission's second spacewalk. During that excursion, they will replace a nitrogen tank on the station's truss. The nitrogen is used to pressurize the station's cooling system. The mission's third spacewalk will see Walheim and Love work outside Columbus to attach 2 European science facilities to the newly installed lab. One experiment package includes a trio of instruments that will study the sun. Another experiment includes a variety of 8 different investigations that will study the space environment. This milestone mission to the space station marks the culmination of several years' efforts by workers around the world to design, construct, and launch the Columbus module. From the Columbus Control Center in Oberpfaffenhofen, Germany, to the Shuttle main engine test stands at Stennis Space Center in Mississippi. From the Orbiter Processing Facility at the Kennedy Space Center in Florida to the Neutral Buoyancy Lab at the Johnson Space Center in Houston. From Michoud, Louisiana to Huntsville, Alabama, thousands of NASA and contractor employees work tirelessly to make sure that the crews are well trained and have the safest, most reliable hardware and facilities possible. Leland Melvin, a former professional football player, understands the importance of teamwork.
I've played in lots of highly functioning teams in my past, and I would have to say that this is one of the most dynamic, highly charged organizations for getting really difficult things done.
It's fun to when you're preparing for it, and even after the mission, to watch the space station fly over and think, wow, we're a part of that. And I hope everybody gets a chance to do that, to look as the space station flies over, and think, that's our space station. There's people living up there, and everybody gets to, you know, say that they had a part of building that, and I think that's very important, and it's a neat feeling.
None of the astronauts on this space shuttle flight grew up with an all-consuming ambition to fly in space, except for the one crew member who will stay on the International Space Station for 2 months when the others go home after delivering the Columbus Laboratory module. The crew is led by Steve Frick, a commander in the United States Navy, who was born and raised in the Pittsburgh suburb of Gibsonia, Pennsylvania.
Great place to grow up, beautiful area, great schools. Most of my family was in that area, and we stayed there all the way through growing up in high school before I left to go to the Naval Academy. I was in college as the shuttle started flying, and you can't watch that as someone who's interested in aviation and flying and not be just absolutely captivated by the experience.
But flying fighter planes came first. Frick earned his bachelor's degree in aerospace engineering at Annapolis, completed flight school, and was assigned to a fighter squadron that deployed in Operations Desert Shield and Desert Storm, where he lived his dream of flying jets off of an aircraft carrier. He followed that with study at the Naval Postgraduate School, where he earned a master's in aeronautical engineering, and a year at the Navy Test Pilot School.
So I found myself in test pilot school with a master's degree, and I had the basic requirements. So I put in an application and basically just got lucky.
Frick was selected as an astronaut in 1996 and made his first flight as the pilot on the 2002 mission that delivered the S-0 truss to the International Space Station. One crewmate from that flight joins him on this mission. Air Force Colonel Rex Walheim is from the San Francisco Bay Area, born in Redwood City and raised in San Carlos. Like Frick, his love of flying dates to his childhood.
My father was a pilot, and so I think a lot of that comes off from him, and he exposed me to flying at an early age with both going to air shows and taking some small lessons and stuff when I was still in high school, and I just enjoyed hearing his stories, and I always just was something in the blood, so I think it came from the genes.
Walheim earned his Bachelor of Science in Mechanical Engineering at the University of California at Berkeley, where he also graduated from the ROTC program and was commissioned a second lieutenant in the Air Force.
And when I got down to pilot training, the doctor said they thought I had a heart murmur, and so they wouldn't let me fly. And so they said, well, where else are you going to go? What are you going to do instead? And so I said, well, I'd like to do some engineering work, maybe come to the Johnson Space Center. And they said, well, now you're going to North Dakota instead.
Where he worked as a missile warning operations crew commander. More than a year later, he was assigned to JSC and worked as a mechanical systems flight controller before he was transferred to a management job at Air Force Space Command headquarters. In the meantime, he had applied for a waiver to be assigned as a flight test engineer at Test Pilot School.
And the interesting thing was when I went to get my waiver for this heart murmur, the doctors said, well, you don't need a waiver because you don't have a heart murmur. And so not only was working as a flight test engineer open, but now potentially NASA could be an option also.
Walheim completed the flight test engineer course and was an instructor at the Air Force Test Pilot School when he was picked by NASA for the astronaut program. Walheim made 2 spacewalks on his first flight in 2002, attaching the S-0 truss to the station's Destiny laboratory. The third spaceflight veteran on this crew is European Space Agency astronaut Hans Schlegel. He was born in the southern German town of Uberlingen on the shore of Lake Constance.
We came from the eastern part of Germany, which was occupied by the Russian side at that time in a socialistic system, and my parents decided pretty close to the Iron Curtain. They can't bear it, so they came over to the western part. We started out in the south, we moved up north. I have many brothers and sisters. We were 9, so they're all spread over Germany.
Schlegel picked up some American brothers and sisters, too, when he spent a year in high school in Council Bluffs, Iowa, as an American foreign exchange student. After completing his military service, Schlegel earned a degree in physics from the University of Aachen, worked there as an experimental solid-state physicist, and then moved to the private sector, studying optical and electrical properties of semiconductor materials. His interest in spaceflight was piqued one night in his lab when he was asked to study a sample of a material grown in space by a German astronaut.
And I said, okay, when we have German astronauts bringing me these samples here, whenever Germany looks again for astronauts, I will apply. And so it just happened. 2 years later, it happened, and I applied.
And he was selected, joining the small corps of German astronauts. In 1993, he served as payload specialist on the German-sponsored D2 Spacelab mission and later trained at the Gagarin Cosmonaut Training Center in Star City, Russia, as a backup for a flight to the Mir space station. In 1998, Schlegel was chosen for the Consolidated European Space Agency Astronaut Corps and was sent to Houston for astronaut training. Another member of that astronaut class is European Space Agency astronaut Leopold Eyarts, a general in France's Air Force who was born and raised in the Basque Country coastal town of Biarritz, just north of Spain.
I think what I inherited from this country is probably it's a country where people usually stick to their goals. They have strong traditions, but also they like adventure, and they like to go and discover the world.
In the case of this native son, the desire was to explore more than just this world.
I decided that I would like to be an astronaut when I was about 12 years old, and I saw the first US astronauts stepping on the moon and walking on the moon. Everything later on that I did at school or in my professional choices, or later in my professional life as a pilot or a test pilot, was driven by the idea of becoming an astronaut one day.
Eyarts left Biarritz at 17 to study math and physics, joined the French Air Force Academy 3 years later, and graduated with a degree in aeronautical engineering. After 11 years flying operationally and as a test pilot in the Air Force, the French Space Agency chose him as an astronaut. Eyarts spent almost 3 weeks on board the Mir space station in 1998, in the days just after American astronaut Andy Thomas arrived for his tour of duty. Later that year, he was recruited by the European Space Agency and assigned to train at the Johnson Space Center in Houston with the 1998 class of astronauts. 3 other members of that class are making their first spaceflight on this mission. Leland Melvin was born and raised in Lynchburg, Virginia, the son of school teachers. Although he was a success as an athlete, his high school teachers inspired him to pursue science, like the chemistry teacher who dragged him to the front of the room so he'd pay attention.
And she was doing an electrolysis experiment, running current into water, separating hydrogen and oxygen. And then we, obviously blew up the balloon and lit a match and blew the hydrogen up. But it was one of those moments that things clicked, and it said, wow, this is what I want to do.
He wanted to play football, too. Melvin earned a scholarship to the University of Richmond, where he played wide receiver while earning a Bachelor of Science in chemistry. He was drafted by the Detroit Lions of the National Football League, but was injured in training camp. So Melvin began doing materials science research at the University of Virginia while he pursued a football career, first with the Toronto Argonauts and then with the Dallas Cowboys, until an injury finished his football dream. Melvin went to work at NASA's Langley Research Center while completing his master's in materials science engineering at Virginia, and became friends with fellow scientist Charlie Camarda before he became an astronaut.
One moment, I remember I was giving a talk, and John Young and Charlie had flown up to Langley, and I gave a talk to a man who had walked on the moon, had flown every vehicle known to mankind, and it was very inspiring, and just that moment said, hey, this is something that would be really, really great to do.
Another member of that astronaut class on this mission is Stan Love. The San Diego native grew up in Eugene, Oregon, where he learned a respect for education and a love of the outdoors. He earned his Bachelor of Science in Physics from Harvey Mudd College.
From there, I wasn't sure what I wanted to be when I grew up. Came back to Eugene, looked for work, ended up in the corn cannery, by which time I was a couple of weeks of that, and hey, send me to grad school.
In 6 years at the University of Washington, Love earned a master's and a doctorate in astronomy and did postdoctoral work at the University of Hawaii and at Caltech.
By that time, I was married and we had a child, and I was tired of being a postdoc in forced temporary positions. So I looked for other things, did all the personality tests and the little things to decide what you should be when you grow up, and the answer came back I should be a planetary scientist, which was no help because I already was one.
But he got an opportunity as a staff engineer at the Jet Propulsion Laboratory and worked on optical instrument systems for spacecraft before he was selected as an astronaut. The pilot on this crew is U.S. Navy Commander Alan Poindexter, a Pasadena, California native who was raised in a Navy family.
My dad was in the Navy, as I am, and we grew up all over the United States, near Washington, D.C., and Rockville, Maryland, and in Virginia, and California, and Florida. we lived all over the place in Washington State as well, and I really enjoyed moving a lot.
After stops at junior colleges in California and Florida, Poindexter moved to Georgia Tech, where he got the inspiration for his professional career.
Dick Truly came to speak, and Admiral Truly spoke about his first night launch and night landing on STS-8. And I was very, very intrigued with it and got to talk to him afterwards. And ever since then, I've sort of aspired to come down here and be an astronaut.
Along with his Bachelor of Aerospace Engineering from Georgia Tech, Poindexter completed ROTC there and was commissioned a naval officer after graduation. He completed flight school and was assigned to a fighter squadron that deployed during Operations Desert Storm and Southern Watch before being selected for test pilot school and, in 1998, for the astronaut program. Poindexter, Love, and Melvin launch on this flight in the company of crewmates with more than 52 days combined experience in space from 4 previous missions.
Good afternoon. I'm Steve Frick. I'm the commander of the STS-122 mission. We're really excited to be here in Florida today, obviously on a tremendous day, and we hope it stays like this all week long, to have our chance to launch in Atlantis on Thursday and bring the Columbus module up to the International Space Station. Obviously, it's been a real long training flow for us, long time building to this moment, and so we're just absolutely ready to go. We know the shuttle program has worked really hard to get Atlantis ready, actually ahead of schedule for this Thursday, and the station folks and Peggy Whitson and her crew up on orbit have worked just tremendous hours in the last month and a half to catch up from the work we had to do on STS-120, the extra work to get it ready so we could actually launch on time. We really appreciate their effort. We only have a week of launch window, so we're real excited to launch successfully on the first try. And I'd like to have my crew come up and each say a little bit, and I'll start with the pilot, Commander Alan Poindexter.
G'day, it's great to be back in Florida, back at the Kennedy Space Center. We flew by Atlantis out on launch pad 39A on the way in, and it's a beautiful sight and beautiful weather today, and we're just very, very happy to be here. We'd like to especially thank the hard-working folks here at the Kennedy Space Center and the launch team and the folks that prepare the orbiters for flight. We'll take good care of Atlantis on orbit, but it's really their ship, and we appreciate them loaning it to us for a couple of weeks. I'll turn it over to MS-1 Leland Melvin.
Good morning. It's great to be back, and we were here, I guess, a couple of weeks ago for the terminal countdown test. Now it's the real day, real time, ready to go for our STS-122 mission. Dex mentioned thanking people here at KSC. We want to thank the people that have supported us in robotics, the robotics trainers and the flight controllers, and even our friends up north and the Canadians. Canadian Arm 1 and 2 will be using extensively to inspect the orbiter as well as to install Columbus and support all the EVAs. And it's just a really great time, and we thank everyone for supporting us and getting us ready. Next, I'd like to welcome Rex Walham, MS-2.
Hi, my name is Rex Walheim, and I'm MS-2. It's great to be back here, especially seeing Atlantis on the launch pad, and it really is exciting to get a chance to go into space again. And I'd like to extend my thanks to the EVA team. As you know, on the last mission, they had to do an extra spacewalk for some contingencies, and that kind of pushed the schedule a little bit, and it was really crunch time. But the whole team, the NASA, the contractors, USA, Hamilton, ILC, all came together, and they executed a brilliant plan, and Peggy and Dan on orbit and Yuri got everything needed to get done and give us a chance. We've got to go, and we got our suits all set up and looking good, and our procedures are ready, and we're really looking forward to a great flight. And with that, I'd like to introduce Hans Schlegel.
Hello, my name is Hans Schlegel. I'm MS-3 on this flight. I'll work in the middeck, outside doing EVAs, and outfitting and activating Columbus. As you probably all know, Columbus is the biggest contribution from Europe for the International Space Station. And from the bottom of my heart, I want to thank all the people in Europe, in the US, and all the other international partners who got us here, who have made Columbus ready for launch. I feel very honored to be a member of this crew who will bring up Columbus for Europe into space. By doing this, launching Columbus, attaching it to the International Space Station, operating it around the clock, Europe will become a senior partner in human spaceflight. And I'm very glad, I'm very proud to be an active part of this team effort. Thank you. Next is Stan.
Hi, I'm Stan Love. I'll be MS-4 on this flight. Us blue suiters are standing out here in front of the cameras and in the spotlight. But while we're flying, it's important to remember that we're only a small part of the vehicle operations team. We'll be working closely with hundreds of dedicated professionals working in control centers around the country and around the world who work 24 hours a day, 7 days a week to support human spaceflight. Next is Leo Ayarts.
I am Leo Ayarts, and it's a great honor for me to be part of this mission.
of the shuttle crew and of the ISS Expedition 16 crew. My first thought would be for all the teams in Europe, in the US and elsewhere who have been making this mission possible. I know that it has been a long wait for them and for us, and I'm sure a lot of people are today happy to see that the Columbus module will soon go to space. What I'd like to mention too is that during my flight in February, we might have also the European cargo carrier, the ATV, which will hopefully blast off from the French Guiana, and that will be another big milestone for Europe participation to the ISS program. And as I will be probably gone for a while, I would like to wish you all a Merry Christmas and a Happy New Year, and see you in 2008.
All right, thanks everybody. We're going to go get in crew quarters and finish our training.
Group shot.
Just a second, let us get a picture shot. Thank you guys. Good luck. See you, Dick.
Überwacht wird das Ganze heute und in Zukunft vom Deutschen Luft- und Raumfahrtzentrum, dem Kontrollzentrum in Oberpfaffenhofen. Und da steht schon den ganzen Morgen Christian Sievers, beobachtet den Countdown. Christian, was ist da zu spüren an Stimmung, kurz bevor es losgeht?
Ja, guten Morgen. Eine Spannung liegt hier in der Luft, und zwar im gesamten Kontrollzentrum in Oberpfaffenhofen. Das merkt man ganz deutlich. Vielleicht auch so ein bisschen Anspannung. Wer so lange auf diesen einen Tag gewartet hat, von dem es heißt, es ist ein epochaler Tag für Europas Raumfahrt, da kann man klar sagen, dass man da natürlich ein bisschen Spannung verspürt. Es heißt, haben wir heute Morgen schon gelernt, in Zukunft nicht mehr Houston, we have a problem. Es heißt Oberpfaffenhofen, we have a problem. Und weil das in Amerika und auch im All keiner aussprechen kann, hat man sich auf Munich geeinigt, also auf München, die nächstgrößere Stadt hier. So, wir gucken mal durch das Herz des Ganzen hier, das Kontrollzentrum in Oberpfaffenhofen. Von hier wird die Columbus-Mission, das europäische Raumfahrtlabor, gesteuert. Und Professor Klaus Wittmann ist Leiter des Raumflugbetriebes. Nicht ganz einfach. Schönen guten Morgen.
Guten Morgen.
Muss man denn diesen Satz, we have a problem, überhaupt sagen, oder läuft alles problemfrei bisher?
Im Augenblick läuft es ohne Probleme, aber den Satz werden wir sicherlich mal hören. Das gehört zu unserem Geschäft.
Okay, aber hoffentlich nicht zu schlimm. Haben Sie denn für alles vorgesorgt?
Also wir haben sehr viele Notfälle natürlich trainiert. Das gehört für uns bei den Simulationen dazu. Aber ich habe viele Missionen gemacht, deswegen bin ich am Starttag auch immer ein bisschen nervös. Es kommen die Dinge, mit denen wir nicht rechnen.
Okay.
Und dann müssen wir gut sein.
Dann müssen Sie gut sein. Europa übernimmt für die nächsten 10 Jahre die Verantwortung. Hier wird alles gesteuert für 10 Jahre. Sind Sie auch ein bisschen stolz darüber?
Ja, das ist für uns eine ganz wichtige Mission. Die trägt dieses Zentrum, die bringt Ausstrahlkraft für uns. Sie sind ja immerhin hier und ich glaube, das bleibt auch so.
Okay, Herr Professor Wittmann, herzlichen Dank. Wir gucken mal kurz hinter mich hier in den Kontrollraum rein und können da sehr, sehr schön sehen, sehr, sehr viele Arbeitsplätze vor den Monitoren. Hier vorne in der Mitte sitzt jemand, der kann tatsächlich mit ein paar Tastaturhandgriffen die Station steuern, beziehungsweise das Labor oben im Weltall steuern, direkt von hier unten aus Oberbayern ins Weltall. Und dann die ganz wichtige Tafel, auf die alle gucken, das ist der Countdown natürlich. Und da schauen wir jetzt auch mal kurz drauf und sehen noch 14 Stunden, 19 Minuten und 28, 27, 26 Sekunden. Und was dann passiert, wenn dieser Countdown auf 0 steht, Das erzählt uns jetzt Carolina Nikodem.
Für die NASA ist es der 121. Flug eines Space Shuttles. Für Europa erfüllt sich ein lang gehegter Traum. Nach über einem Jahr Wartezeit kann die ESA endlich ihr Forschungsmodul Columbus in die Umlaufbahn bringen. In dieser Tonne verbirgt sich das vollständig ausgestattete Weltraumlabor. Es ist der wichtigste Beitrag der Europäer zur internationalen Raumstation. Gleich nach Ankunft wird das Modul mit Hilfe eines Roboterarms an seinen Platz geschwenkt. Der deutsche Astronaut Hans Schlegel wird dann in den freien Weltraum aussteigen und es befestigen. Im virtuellen Studio hat er jeden Handgriff wieder und wieder trainiert.
Die erste Aktivität ist, die einfach physikalisch von einer Stelle zur anderen zu bringen. Das nächste ist Kühlung, elektrische Versorgung direkt anzubringen, Experimenteinschübe einzubauen und dann irgendwann ein Experiment hochzufahren, was erst dann passiert, wenn das Shuttle schon längst abgedockt hat.
Mit seinem Flug wird Hans Schlegel Geschichte machen. Denn mit dem Columbus-Modul bekommt Europa zum ersten Mal ein eigenes Arbeitszimmer im Weltall.
So, und jetzt sind wir live in diesem Arbeitszimmer im Weltall, im Labor, im Columbus-Labor. Naja, gut, wir sind live in einem Modell des Columbus-Labors. Die erste Problematik ist, das Ganze natürlich anzudocken. Hier muss es ran an die internationale Raumstation. Und das hat man sich ein bisschen so vorzustellen, wie wenn einem eine neue Waschmaschine geliefert wird und der Monteur erstmal die Anschlüsse prüfen muss. Da hat es auch schon Probleme gegeben. Wenn so ein Anschluss nicht passt, dann kann natürlich erstmal gar nichts gehen. Und fragen wir mal Reinhold Ewald, den Astronauten, der damit viel Erfahrung hat. Guten Morgen, Herr Ewald.
Guten Morgen, Herr Sievers.
Können Sie das Ding da wieder mit zurücknehmen, wenn der Anschluss nicht passt?
Ja, wir müssen es zurücknehmen können, denn das Shuttle muss auch mit einer vollen Nutzlastbucht noch landen können. Aber wir hoffen alle, dass das also nicht vorkommt und dass die Ingenieure richtig gerechnet haben.
Okay. Farbe ist zwischendurch mal abgeplättelt im Inneren. Das darf nicht passieren, da musste neu gestrichen werden. Denn wenn so Farbreste rumschwirren, was passiert dann im All?
Der erste Eindruck, den wir vom Columbus-Modul haben werden, ist also am Flugtag 5, wenn die Tür aufgeht und die Astronauten werden Brillen und auch solche Mundschutzmasken tragen, eben damit keine Fremdkörper, die irgendwo rumfliegen, bei ihnen in die Lunge gelangen können. Aber dann geht es, glaube ich, schon schnell mit dem normalen Betrieb los. Hemdsärmel, gute Luft und auch ausreichend Gelegenheit, dann die Experimente in Betrieb zu nehmen. Vor allen Dingen.
Okay, ich komme auf die andere Seite hier ein bisschen von Ihnen, gucken wir uns das nochmal genauer an. Warum brauchen wir solche Experimente dauerhaft überhaupt im All? Warum kann man das nicht auf der Erde testen?
Ja, Columbus setzt ja eine Tradition fort, die mit Space Lab zum Beispiel für 10 Tage, 14 Tage im All schon in den 80er, 90er Jahren erfolgreich getestet wurde. Und wir haben jetzt die Möglichkeit, 24 Stunden ununterbrochen als Teil der Raumstation dann diese Experimente fortzuführen. Großer Fortschritt.
Sie sind Astronaut, Herr Ewald. Juckt es bei Ihnen so ein bisschen in den Fingern, wenn der Herr Schlegel, der deutsche Astronaut, der jetzt heute hochfliegt, sagen würde, ich habe doch keine Lust, mach du weiter? Würden Sie sagen, natürlich?
Also wir haben ja voriges Jahr Thomas Reiter mit Astrolab gehabt, wir haben Kollegen Vogelsang und auch Paolo Nespoli im All gehabt mit Ausstiegen. Hans Schlegel wird unser Modul per EVA, also mit Außenausstieg an die Raumstation ankommen. Klar möchte man dabei sein, aber es ist ein langes Training, es ist sehr viel Vorbereitung.
Okay, wir können kurz auf Bilder gucken, die wir von der NASA bekommen haben. Die internationale Raumstation da oben, 400 Kilometer über der Erde. Kann man sie vom Boden aus eigentlich sehen, Herr Ewald?
Sehr gut. Es ist ein sehr helles Objekt, das sich von Westen nach Osten bewegt. Also wenn Sie mit der entsprechenden Information aus dem Internet dann zur richtigen Zeit hochgucken, Sie werden die Raumstation nicht verpassen können.
Das werde ich jetzt gleich überprüfen. Reinhold Ewald, Astronaut, herzlichen Dank. Wir gehen raus. Ja, vielleicht haben wir ja eine Chance, was zu sehen, direkt live hier am oberbayerischen Morgenhimmel. Ein paar Schritte. Jetzt sehen wir natürlich schon, es ist bewölkt, ja, die Regenwolken. Wir gucken trotzdem mal hoch ins All. Das ist der Weltraum über Oberbayern. Ich sehe die ISS ehrlich gesagt nicht, aber das kann auch an den tief hängenden Wolken liegen. Ja, zum Schluss vielleicht ein Satz von Hans Schlegel, dem deutschen Astronauten, der heute ins Weltall startet. Der wurde gefragt, haben Sie eigentlich Angst? Haben Sie ein bisschen Angst vor dieser Verantwortung? Und da sagt er, Angst? Nein, nennen wir es Respekt. Zurück nach Berlin.
Vielen Dank. Christian Sievers in Oberpfaffenhofen. Respekt also vor der Columbus-Mission. Dieses Modul wird heute ins All starten. Das Labor der Europäer für die ISS. Tscherno.
This is Shuttle Launch Control at T-minus 3 hours in holding, where the countdown clock is going to remain. We did have some difficulty this morning shortly after we began fueling the external tank with liquid hydrogen and liquid oxygen. And here with us at the console in the firing room is Doug Lyons, who is the STS-122 launch director. Doug, tell us exactly what happened and when it happened.
Okay, I'll do that, George. Of course, we're a little disappointed in the events today, but we're certainly working to resolve our issues and make an attempt as soon as we possibly can. The failure was a LH2 low-level liquid sensor, and folks are probably familiar with those. We also refer to them as our eco sensors. And we had a failure of sensor number 3 and number 4. And in the system, we have a total of 4 sensors. The failure occurred during tanking around 16 minutes into fast fill. We picked it up while implementing our standard checkout of the system. As soon as we get these sensors wet, we go through a battery of checks to make sure that they're operating nominally and properly. And we were at a point in the test where we send commands to take all 4 sensors dry. And when we did that, sensors 1 and 2 went dry as expected, and sensors 3 and 4 went wet. And right then we knew we had an issue, and we stopped and we picked up interim problem report. And we have pre-planned procedures, troubleshooting procedures, and we put those in place and started working through our troubleshooting and collecting data so that we could try to understand exactly what the situation was and why we were having this problem. So we remained in that configuration and continued tanking and did our troubleshooting and collected all the data that we could possibly collect. And preliminary indications are that we have an open circuit there. But again, we've got to do some additional engineering analysis and evaluation to see if that is the problem. And then more importantly, where that open circuit is, whether it's a connector or a splice line or something of that nature. And once we isolate that, then we can determine the appropriate corrective action.
Now tell us briefly what these sensors are doing. What are they for? Why do we need them?
Well, the sensors, as a set, are a redundant engine cutoff system. The flight software, and the engine controllers run the engines through ascent, and at the proper time, they've got timers. At the proper time, they'll cut off the engine. And this is a backup to that. If for some reason we're depleting LH2 faster than we had thought, when these sensors go dry, they will send commands to cut off the engine to ensure that we have a safe engine cutoff and our LH2 quantities don't get too low. So it is a redundant system, but it is a system that's critical to us, and so we certainly want it to operating to go fly.
Now, what do we know about the status of the sensors themselves?
Well, they're part of the failure tree. There's wiring from the point sensor box, which takes the readings, and there's wiring through the orbiter aft into the external tank to the sensors. So the sensors are located inside the LH2 tank, and of course they were functioning when installed and checkout. They've been through checkouts, as we've gone through our processing flow from build all the way to reception, all the way down to the pad. Of course, this is the first time that they've seen cryos. So, it's certainly something that the engineering folks are looking at and maybe contributing to this condition.
What's the launch team doing now? Where do we go from here in the troubleshooting and try to determine what's wrong?
Well, as I said, we've collected, a great deal of data through our troubleshooting. And engineering folks and the subspecialties are looking at that data now. The plan is to get that collective technical team together at noon today and look at all our options, and then based on those options and narrow them down to the ones that are best, and then we'll take those options to the mission management team, and they're going to convene at 1400 today. So coming out of that meeting, we should have a good forward plan and know what direction we're heading. In terms of the countdown, what we've elected to do, we are currently in stable replenish, and in that configuration, it is safe to send folks out to the launch pad. So In order to get an idea of how the tank is performing in terms of ice and the foam, we did send our final inspection team out to the pad, and they are going to do a expedited inspection of the tank. We want to try to get in the drain a little quicker. Usually they run about 2.5 hours for their inspection. We've asked them to narrow that down to an hour, and they're doing that by going to targeted key areas of interest on the tank. So that'll be valuable data in terms of the condition of the tank for our ET folks and our systems engineering and integration project. So we thought that was smart to go do. After that hour is up, we'll go ahead and ask them to clear the pad. When we do that, we'll go into drain the LOX and LH2 tanks. That runs a couple hours. And then what our plan is to do is to get into a 24-hour scrub turnaround posture. And we've got procedures that allow us to go do that. And so that's our forward plan here in the firing room and here with the countdown. We want to make sure we preserve the capability to go tomorrow if that's what the technical community determines is the right thing to do. So we're keeping all our options open, and again, I really don't have more to tell you, than that, other than
Will
more
they
to
do
come.
any troubleshooting as we detank, or do we have what we need at this point?
Well, that's a very good point. There is some troubleshooting that they'll do during detank, and it essentially involves watching. We've got voltages that monitor these two sensors, and the voltage is high now, indicating an open circuit, and they'll monitor those and see if they go closed, just to get some additional data that might give them an idea of where the problem is. So they'll be doing troubleshooting. It's not really active troubleshooting, it's mostly monitoring, but that data will be used in their engineering evaluation.
All right, Doug, well, thanks very much, and we'll look forward to seeing and talking with you again at approximately 4 o'clock after the mission management team meeting, along with the chairman of the mission management team, Leroy Kane. So, Doug, thank you, and we'll let you go back to the console to work on our detanking operations now, since I gather we're either, are we detanking now or about to go into that?
No, we're in replenish now with the final inspection team out at the pad. While they're out at the pad, we need to stay in stable replenish. So once they do clear the pad, and that'll be somewhere within an hour now that they've been out there for a while, at that point, when they're clear, we'll go from replenish to detanking. So I would estimate probably around 11:30 we'll be in a position to detank, and we've got a couple hours to do that.
All right, Doug, thank you very much for coming over to talk with us, telling us where we are in this situation, and we'll be talking with you later this afternoon. Thanks very much.
Okay, and can I make one more comment?
Sure, please.
Okay, and just in terms of the team remains in good spirits, and we really are confident that we can work our way through this and get a few launch attempts in this window. So we still have hope and reason to believe that we're going to get off in December, and that's where we're all shooting, and again, we're confident we'll get there.
All right. Thanks, Doug, and hopefully we'll be back here tomorrow for another launch attempt if we can do that. Thanks very much, and that will conclude our quick status. Our next event will be the Post-Mission Management Team Press Conference at approximately 4 p.m. this afternoon. This is Shuttle Launch Control.
Es gab Probleme mit dem Tank, so die NASA. Ursprünglich sollte das Shuttle heute Abend starten. Das Ziel, die internationale Raumstation ISS, wo Columbus angedockt wird. Zur Mannschaft gehört auch der deutsche Astronaut Hans Schlegel.
Tja, Enttäuschung für die europäische Raumfahrt, meine Damen und Herren. Wegen technischer Probleme musste der Start der US-Weltraumfähre Atlantis mit dem europäischen Weltraumlabor Columbus und dem deutschen Astronauten Hans Schlegel an Bord um mindestens 24 Stunden verschoben werden. Das Ganze hätte um 22 Uhr unserer Zeit stattfinden sollen. Sollte es Freitagnachmittag ungefähr der nächste Starttermin wieder nicht klappen, dann endet das Zeitfenster am 13. Dezember. Das ist, glaube ich, der Donnerstag der nächsten Woche.
Abschussbereit wartet die Atlantis auf dem US-Weltraumbahnhof Cape Canaveral auf ihre Startfreigabe. An Bord der Space Shuttle befindet sich das europäische Weltraumlabor Columbus. In diesem Labor kann die Europäische Raumfahrtbehörde erstmals selbst bestimmen, wann und wie sie welche Experimente durchführt. Ins All wird Columbus daher auch unter anderem von 2 ESA-Astronauten gebracht, dem deutschen Hans Schlegel und Leopold Eyharts aus Frankreich.
Mit Columbus wird die internationale Raumstation wirklich international. Außer amerikanischen und russischen Lebensmodulen, wo also Menschen drin leben können, haben wir ja noch keine. Aber das europäische Modul wird dann die 3. Nation sein oder die 3. Konglomerat von Nationen.
Jahrelang mussten die Europäer auf diesen Moment warten, denn eigentlich sollte das Labor schon 2004 ins All. Doch als die Raumfähre Columbia am 1. Februar 2003 beim Eintritt in die Atmosphäre verglühte, wurden erst einmal alle Shuttleflüge auf Eis gelegt. Columbus ist ein etwa 7 Meter langer Zylinder mit 4,5 Meter Durchmesser. Bis zu 3 Astronauten können in ihm gleichzeitig Experimente durchführen. Nach mehreren Außeneinsätzen soll das Labor an die ISS angedockt werden, keine leichte Mission.
Wer da nicht ein gewisses Gefühl des Respektes, meinetwegen auch der Angst hat, der wäre nicht normal.
Während sein französischer Kollege 2 bis 3 Monate im All bleiben wird, darf Schlegel gleich wieder nach Hause. Planmäßig soll er noch vor Weihnachten zur Erde zurückkehren.
Technischer Probleme den Start der Raumfähre Atlantis verschieben auf frühestens morgen Abend. Unter den 7 Besatzungsmitgliedern ist auch der deutsche Astronaut Hans Schlegel. In einem Außeneinsatz wird er das europäische Weltraumlabor Columbus an die internationale Raumstation ISS anschließen. In dem Labor sollen in den nächsten 10 Jahren wissenschaftliche Untersuchungen unternommen werden auf den Gebieten der Medizin, Grundlagenphysik und Materialforschung.
Europa wird mit dem Weltraumlabor erstmals Mitbesitzer der internationalen Raumstation. Die Experimente könnten helfen, Krankheiten zu kämpfen, bessere Werkstoffe zu entwickeln und die Umwelt zu schützen. Für den 56-jährigen Vater von 7 Kindern wird die Montage im All die größte Herausforderung seines Berufslebens.
Der Start der Raumfähre ist erneut verschoben worden. Nun soll sie frühestens morgen in Cape Canaveral abheben, weil 2 Tanksensoren weiterhin Probleme machen. An Bord des Fluges zur internationalen Raumstation ISS sollen auch der deutsche Astronaut Hans Schlegel und das europäische Columbus-Labor sein.
Abend von Cape Canaveral zur Raumstation ISS aufbrechen, unter der Bedingung, dass dann alle Sensoren am Treibstofftank funktionieren. An Bord des Shuttle ist das europäische Weltraumlabor Columbus. Zur Besatzung gehört der deutsche Astronaut Hans Schlegel.
The original launch was scrubbed after 2 fuel sensors failed pre-flight tests. NASA officials say the fuel sensors will have to perform flawlessly in the run-up to the launch. During the shuttle's 11-day mission, it will install Columbus. That's a high-tech lab that's considered crucial toward completion of the International Space Station. CNN will cover the launch live Sunday at approximately 2000 GMT.
Startfrei nach mehrmaligem Aufschub wegen technischer Pannen soll der deutsche Hans Schlegel heute Abend mit der Atlantis ins All fliegen. Nach mehreren Startverschiebungen wegen technischer Probleme soll die US-Raumfähre Atlantis mit dem europäischen Weltraumlabor Columbus und dem deutschen Astronauten Hans Schlegel an Bord noch am heutigen Sonntag ins All fliegen. Bedingung ist allerdings, so die NASA, dass alle 4 Sensoren am Triebwerktank der Raumfähre reibungslos funktionieren.
Stunden vor dem Start herrscht Anspannung bei Hans Schlegel und seinen 6 Kollegen. Denn noch ist nicht ganz klar, ob ihre Raumfähre Atlantis heute Abend wirklich starten kann. Erst wenn alle Treibstoffsensoren voll funktionstüchtig sind, können Schlegel und seine Mitstreiter ihre Mission in Angriff nehmen. Sollte die Starterlaubnis erneut nicht erteilt werden, wird es eng für die NASA-Astronauten. In diesem Jahr ist ein weiterer Startversuch nur noch bis zum 13. Dezember möglich. Ein weiterer dann erst wieder im Januar. Die Ursache für den Defekt haben wir bis heute noch nicht gefunden. Aber wir haben jetzt jedes betroffene Teil in dem System überprüft. Das Space Shuttle soll das europäische Weltraumlabor Columbus zur Raumstation ISS bringen. Hans Schlegel wird einer von 2 ESA-Astronauten an Bord sein. In mehreren nicht ganz ungefährlichen Außeneinsätzen soll er mithelfen, das Labor mit der Raumstation ISS zu verbinden. Im europäischen Kontrollzentrum des Forschungsmoduls Columbus in Oberpfaffenhofen bei München werden mit dem Start große Hoffnungen verbunden. Die Europäische Raumfahrtbehörde wird mit Columbus erstmals selbst bestimmen können, wann sie welche Experimente ausführt. Langfristig ist eine kommerzielle Nutzung geplant.
Tja, also bereits heute Abend kann es also wieder spannend werden. Telefonisch verbunden sind wir nun mit Friedhelm Claassen vom Deutschen Zentrum für Luft- und Raumfahrt. Schönen guten Morgen. Erstmal, wie optimistisch können wir denn sein, dass es nun heute Abend klappt, Herr Claassen?
Ja, guten Morgen nach Köln. Optimismus ist angesagt, denn häufiger sind diese Sensoren schon ausgefallen und wir haben jetzt verschärfte Startregeln. Nicht nur, dass 4 von den 4 Sensoren funktionieren müssen, es muss auch noch das Monitoring einwandfrei laufen und das Startfenster ist jetzt auf 1 Minute verkürzt worden.
Insgesamt muss die Anspannung natürlich für die Astronauten und auch für Hans Schlegel natürlich sehr, sehr groß sein. Was geht in diesen Männern jetzt vor, die auf diesen Start warten, die aber natürlich auch sicher gehen wollen, dass alles am Ende wirklich reibungslos läuft?
Zunächst mal gilt für den Start, dass er von den Randbedingungen her sicherer ist als sonstige Starts, weil eben 4 von 4 und nicht nur 3 von 4 Sensoren funktionieren müssen. Da können die Astronauten also sehr beruhigt sein, brauchen sich um den Start keine Sorgen machen. Die Arbeit im Raum selber, dann Aufbau der Station, Anbringen des Columbus-Moduls wird sehr anstrengend sein, aber natürlich auch mit den üblichen Sicherheitsvorschriften bei Außenbordaktivitäten durchgeführt werden. Also ein normales Risiko.
Also ein normales Risiko für die Astronauten. Was wäre denn nun im schlimmsten Falle, sagen wir mal, es kann heute Abend also doch nicht gestartet werden. Was würde das auch für den Aufbau der Raumstation ISS und auch für das europäische Raummodul Columbus bedeuten?
Es würde sich ein weiterer Verzug ergeben. Das nächste Startfenster ist erst Anfang Januar wieder verfügbar und wir würden dann wieder einige Wochen zusätzlich verlieren. Das wäre natürlich sehr ärgerlich. Wir warten jetzt alle darauf, dass wir das Columbus-Modul tatsächlich in Betrieb nehmen können, dass wir sozusagen einen neuen Partner Europa und auch damit Deutschland auf der Station haben, nicht nur im Prinzip Amerika und Russland, sondern eine wirklich internationale Station mit 3 großen Partnern dann, die aktiv mit eigenen Modulen vertreten sind.
Wie groß ist denn die Bedeutung für die europäische Luft- und Raumfahrt, dass eben das heute Abend gelingt und dass der Aufbau dieser Station gelingt?
Das ist ja nicht nur das Columbus-Modul. Als nächstes haben wir das europäische Versorgungsfahrzeug ATV, automatisches Transferfahrzeug, was im Februar zur Station starten soll und damit auch die europäischen Anteile in der Versorgung der Station aufnimmt. Und dann natürlich über 100 Experimente sozusagen auf der Warteliste, die endlich durchgeführt werden sollen im Columbus-Modul im Laufe der nächsten Jahre.
Ja, vielen Dank für diese Informationen. Friedhelm Claassen war das vom Deutschen Zentrum für Luft- und Raumfahrt. Heute Abend also heißt es Daumen drücken, dass es klappt mit dem Start der Atlantis.
This is Shuttle Launch Control at T-minus 5 hours, 5 minutes, 10 seconds and counting. The liquid hydrogen sensors have been cycled and they are all confirmed to be working properly. Once again, at this time, all 4 liquid hydrogen sensors are working. We'll continue to monitor those sensors over the course of the next couple of hours. Fast fill of liquid hydrogen is continuing, and so is liquid oxygen without any incidents. This was somewhat predicted based on past tanking attempts when we've had a problem with the sensors and then tanked a second time and the sensors have worked properly. So right now, this is consistent with our experience base, and all 4 hydrogen sensors are currently operating. This is Shuttle Launch Control at T-minus 5 hours, 3 minutes, 40 seconds and counting. We've just received word from the liquid hydrogen propulsion console that one of the liquid hydrogen sensors, number 3, has failed. Standing by for further action. The plan would indicate that troubleshooting would now proceed. Once again, liquid hydrogen sensor number 3 has failed. This is not good news. So after what we thought was a good indication of having 4 sensors in the green, one of them has failed. This is not good news. Confirmation now that we have scrubbed for today. That direction coming from Leroy Kane, chairman of the mission management team, and Doug Lyons, the STS-122 launch director. Right now we continue with troubleshooting before any detank operations begin. And we have now gotten a go to begin the draining of liquid oxygen. Liquid hydrogen will stay as is for the present until liquid oxygen is drained, and then we'll move into a liquid hydrogen drain. And we'll dedank hydrogen down to the 5% point, at which point we'll collect more data and then drain down to 0. Or until it boils off, whichever occurs first. This is Shuttle Launch Control. We're in firing room 4 of the Launch Control Center, where STS-122 Launch Director Doug Lyons has joined us to talk about the circumstances this morning. And Doug, first of all, tell us exactly what happened this morning and when it happened.
Okay, well, as planned, we came in and picked up with our tanking operations, and there's a sequence of events we go through. We chill the lines down, and we get in a slow fill condition. Both the cross-country, the lines, our facility lines, as well as the orbiter, and ultimately we get into what we call fast fill, and that's where we've been experiencing these failures. So we were going through that process. We had gotten to fast fill. We've got 2 things we look at: the voltages on the circuit, and those were all good on all 4 circuits. And we also look at the discretes, whether they're indicating wet or if they're indicating dry. And all of them went wet as expected. And then once we were in fast fill for roughly 10 minutes or so, we went and did the system checkout, and that's when we send simulated dry commands to the sensors sequentially and see if they go from wet to dry. And if they do operate in that manner, that's what we're expecting, and that's a good checkout. And so we were watching, of course, with great interest here in the firing room, and we had a lot of the MMT members on. And we started to test. We went to sensor number 1 and went dry. Sensor number 2, it went dry. Sensor number 3, and if you recall, 3 and 4 were the ones that failed last tanking. 3 went dry and 4 went dry. So it appeared, and I should say also that all the voltages were reading good readings and good values as well. So it looked like we had a good system, and of course the firing room was, we were very excited and felt like we had a good system, and we're going to be ready to go fly today. And we continued to monitor the system, and 2 or 3 minutes after this test was run, they were all dry, and we were keeping them in that condition. And then we saw sensor number 3 go from dry to wet, which was a failure. And at that point, based on our revised LCC, which called for 4 of 4 sensors, we were scrubbed for the day. We conferred with our system engineers, and indeed we were getting a failed signature. So we went and had a discussion with the ops manager, and we did indeed scrub for today.
Well, I think at this point, though, there was a fair amount of planning as to what we wanted to do should this happen. Can you tell us a little bit about the plan and where you think we're going from here?
Yes, we, as we mentioned yesterday, we do have a troubleshooting plan in place. First thing we did was we went through a suite of commands where we send the wet-dry commands to the sensors, and that's our standard troubleshooting plan. That went into work immediately. And again, when we got through that, sensor number 3 did remain in the failed condition. At that point, we went into something a little non-standard for us, trying to gain a little better insight into the system and collect some more data. What we did is we stopped the flow on the LH2 system and put it in a quasi-stable posture or condition. Our configuration, I should say, and then we went and we're draining the LOX tank, and the plan is to get the LOX tank drained, and then we'll focus on LH2 tank, and we're going to drain the LH2 tank down to the 5% sensor and stop there, and then monitor the system for anywhere in the area of about 4 hours to see how these sensors behave, and then at that point we'll continue with the LH2 drain and then secure the pad.
Now, this failure today is different than the way it failed the other day. Can you draw some contrast between the two?
Well, the only difference is that on Thursday, sensors 3 and sensors 4 failed. In this case, only sensor 3 failed, but they failed in generally the same time frame and in the same manner. So there are some similarities. We have seen in the past when we've had an open circuit and we've come back and tanked that the sensors, corrected itself and operated properly, and that's what we did see on sensor number 4, but we just didn't have any joy with sensor number 3.
I might be asking you to be a little bit clairvoyant, but where do you think we go after today?
Well, we have a 9 o'clock mission management team meeting, and we'll be discussing our options and our forward plan. And it would be speculation on my part at this time to try to make a guess on which direction we head. But we do have multiple options, and folks have been thinking about what ifs if we didn't have a joy today. So we'll put something together and be ready to implement it coming out of that meeting.
Well, Doug, thank you very much for telling us the situation and the circumstances, and we'll just await the conclusion of the mission management team meeting to see what the strategy is and where we go from here. Thanks very much.
Okay, you're welcome.
And this will conclude our coverage on the attempted launch of Space Shuttle Atlantis this morning. We will have a press conference whenever the mission management team meeting concludes. But in the meantime, this will conclude our coverage of our launch attempt today. From Firing Room 4 of the Launch Control Center, this is Shuttle Launch Control.
Good morning. I'm John Yemmer, NASA Public Affairs. Welcome to the Post-Mission Management Team News Conference following the scrub of Space Shuttle Atlantis' STS-122 mission. Here to give us an update is Associate Administrator for Space Operations, Bill Gerstmeyer, Mission Management Team Chairman, Leroy Kane, and STS-122 Launch Director, Doug Lyons.
Morning.
We'll start with an update and then take questions. Mr. Gerstmeyer.
Thanks, John. First of all, I think we're probably all a little disappointed we didn't get to see a launch today, but I think we need to step back and look at in bigger perspective of what really has been accomplished. At the beginning of this year, the fact that we even had a chance at December is a real tribute to both the station team and also the shuttle processing team and the shuttle program here at KSC. So we should all be really proud, and we ought to congratulate that team for giving us a chance to be ready to launch on December 6th. They've done a phenomenal job of getting ready to go do that. They continued with a great job of putting together a great plan that we tried to execute today. The criteria that they established for the launch was exactly right. It gave us the chance to fly safely. And it also protected the option, in case we had what we had today, a chance to preserve the data and potentially go back and understand what's going on with our engine cutoff sensors. So again, the team has done a tremendous job, and they should all be congratulated for getting us a chance to even launch in December, and they ought to be congratulated for putting together a great launch plan and executing it properly today. So my hat goes off to that team, and I'll stand by to answer your questions. I think one thing I'll also say at the beginning is, if you look at what this means moving into January from a big picture standpoint, it's not that big an impact to us overall. It won't impact the next mission. The February flight, we'll be able to accomplish that on time as it's planned. There's also some scheduled time between that February flight and the April flight. There's a couple weeks of margin in there, so that can slip to the right. So from a big picture standpoint, it's really not an impact to us overall from a mission assembly standpoint or assembly of space station standpoint. There's enough margin in the system that we can accommodate this move into January without a big impact. So again, in the big scheme of things, it's a slight disappointment, but still from an overall standpoint, it's not a big deal. Okay, Leroy?
Okay, thanks, Bill. Good morning. We would rather have launched today, obviously, but as we talked to you about yesterday, this was going to be, in the very least, a good tanking test for us, and that's what it's turned out to be. We're taking full advantage of the opportunity to gather some data here for a failure that's been very hard for us to get to the bottom of, and the best thing we can hope for is that it'll repeat for us even after today, and so we're going to glean as much from this as we possibly can. We came in this morning and we did our tanking briefing, and everything was nominal, of course, and gave a go for tanking. The team showed up per the plan, and we started the tanking sequence. As you've heard, we did have one of the engine cutoff sensors failed to the wet state. Our criteria was that we needed 4 of 4. And so therefore we're here talking to you today. We, as a program, we have done a few things. Starting today, we set up what we're calling our short-term KSC troubleshooting team to put together brainstorm ideas and troubleshooting methods that we might want to go do for the system that we have out at the launch pad. And they're going to report out for the first time to the program board, the PRCB, on Tuesday of this week. From there, we will determine what steps we take in the way of troubleshooting the system we have out at the launch pad, to include possibly a tanking test, to include possible look at some of the feed-through connector areas and other connecting and wiring and cabling areas. So I don't want to get out in front of that team. They have the work cut out for them, but they will bring their recommendations to us on Tuesday, and then we'll move out smartly on implementing some of the troubleshooting plans that they bring forward. From there forward, we're targeting the early January time frame preliminarily here, and we'll see if we can make that for the vehicle and the system we have out at the launch pad. It's all going to depend on what we find out when we go begin to do some more in-depth troubleshooting. So with that, I probably can't echo some of Bill's comments loud enough to really give it justice, but the team that even put us in a posture to be able to be ready to go fly here in early December, and then beyond that, for us to be able to come back today and execute what turned out to be a tanking test. I can't say enough about how hard they've worked. As I said to you the other day when I was here, it's a very flexible team, and they're very determined. And again, I just appreciate all the efforts across the entire team, even beyond the KSC shuttle processing and engineering team here. It's been a huge team effort across the agency. So we're really proud of the team. We're going to go get some good data, and we're determined to get to the bottom of this. And with that, I'll let Doug talk to you about the vehicle and some of the details of what we saw today.
Okay, thank you very much, Leroy, and hello, folks. Well, we gave it a good try today. The launch team did an outstanding job over the course of the evening, and we picked up tanking this morning right on time. We went through our standard sequence, our loading sequence, and about an hour in or so, we picked up with fast fill. All our eco-sensors went wet as expected. And at that point, we started running through the system checkout and test, and I think I mentioned this from the flying room. But the way that goes, it's a sequential test, and we send a dry command to each of the 4 sensors, And we were kind of, well, we were very excited in the firing room because as we commanded the sensors to go dry, sensors 1 and 2 went dry, and then 3 and 4 also went dry. So we were very encouraged by that. We were also monitoring the voltages of those sensors, and they all were operating nominally as well. So we felt pretty good about it. 2 or 3 minutes later, sensor number 3 failed, and with that, we got with our console operators and confirmed that indeed it was a hard fail. We had the wet indication as well as the voltages went up, indicating an open circuit. So we had an LCC violation based on our 404 criteria, and we went to Leroy and the ops manager with our recommendation that we were no-go for today, and we scrubbed the tanking operations. And where we are now, as soon as we made that decision, we went into a troubleshooting plan that was laid out over the course of the evening, and we're currently in work with that plan. We think we'll finish up the troubleshooting around 1:30 or 2 o'clock this afternoon. At that point, we'll complete the tank drain and then go into our standard pad securing operations and back out of the countdown. At that point, we'll rotate the rotating surface structure around, back around the vehicle and then gain the access we will need to do whatever troubleshooting this team determines we need to go do. In closing, I think the team is disappointed but highly motivated to go help this team correct the problem, go execute this troubleshooting, and get us back into a launch posture. And all our focus and energy is directed in doing that.
Thanks, Doug. We'll now take questions here at Kennedy Space Center. Try to hold to one question initially because we do have a question from Johnson Space Center, and then we'll come back around for some more. Remember to wait for the microphone, state your name and affiliation to whom your question is directed. Marcia?
Marcia Dent, Associated Press, probably for Leroy. Do you envision having to find root cause before you fly again?
Well, we're certainly going to set out with that intent, Marcia. In this case, with the vehicle and the system we have at the pad, we feel like we need to try to find root cause, and we're going to make every effort to do that. Beyond that, as far as our path forward, it would be speculation for me at this point. Our main focus right now is given the repeat failure that we had today, we have a lot of hope and confidence that we know how to get in there, but we're very hopeful that it'll repeat again in a fashion that we can capture it and be able to narrow down the area that's causing the problem, whether it be in the tank or outside of the tank or somewhere in the connectors. That's really our main focus right now. So we're going to do everything we can with the system we have at the pad, given the indications that it's shown us. We're going to follow that data to the extent we're able to, and anything beyond what we find out from that would be speculation, and I just wouldn't want to do that based on what we know today.
Mark?
Mark Carreau from the Houston Chronicle. I guess I'm looking for a little explanation here on what you sort of mean by root cause and how you're better postured now to go after root cause than you were a couple of years ago. What do you have that can get you there that you didn't have before?
That's a good question, Mark. We have, at least in this case, as you recall on Thursday, ECO number 3 and 4 both failed to this wet state, open circuit, I should say. And today, it looks as though ECO 3 failed in the same fashion. It did, in fact, fail open circuit. The difference was it failed a little bit earlier. The Thursday failure was about 16 minutes into the fast fill. In this case, 2 minutes into the fast fill is when ECO number 3 failed wet, and it appeared to stay in that failed open circuit configuration, at least last we know of it. We still have propellant in the tank, and we're still doing troubleshooting down at those lower levels. So what that does for us, Mark, is because it has repeated, which we've not seen before in this same fashion, our hope is that we can go do some troubleshooting, potentially to include some instrumentation in certain areas, and then potentially a tanking test to wet the sensor again and get the system and the environment around the system down to cryogenic temperatures again, and see if we can repeat it and really nail down, with some instrumentation perhaps, we can really nail down what part of the system the failure might be in. So that is what we're hoping for. We're frankly hoping it repeats whenever, if and when we get to that point. And again, I'm at risk here of getting a little ahead of the team that's going to bring some recommendations in on Tuesday, and so I don't want to really say too much more than that because it wouldn't be appropriate. But that's the kind of thing, notionally, that we're talking about.
Bill, and then over here.
Bill Harwood, CBS, probably for Leroy, I guess. Realizing that Norm Knight and the guys at MCC are very clever people, I mean, is there also any chance that with this instrumentation, you guys, now that you have some more time and you're not in the heat of the countdown, you could develop some different rationale for flying with less than a full set of sensors based on the modified flight rules and all of that? Thanks.
Well, there's a possibility of that. There will be none of those kinds of things that we leave unturned in the way of stones where this problem is concerned. So we're going to look at everything, Bill, and I'm sure that will be part of what we look at. The flight ops mitigation plan that we put in place, we feel very good about, and as we always do, we'll continue to review that as we go forward. And if we can be smarter, as you say, they are very clever folks and a lot of capability there in mission control. And so I'm sure we'll continue to review and refine that and maximize our capability there, just like we will in some other areas.
Back here.
Hi, Holly Hickman, Fox News Radio. Just to follow to that, in terms of using the instrumentation as part of the launch criteria you would have used today during the entire flight instead of just pre-launch, and using basically 4 of 4, or making sure that they keep to 4 of 4 instead of under. Do you think you would keep to that if you don't find root cause?
You know, that's TBD also, and the reason I say that is because all of our efforts are going to be, first of all, to do some troubleshooting on this system that we have at the pad to try and capture, finally, maybe, to try and capture this failure mode. Once we do that, we're going to follow the data wherever it leads us in terms of further troubleshooting and or what might end up being root cause. And so if we, in fact, ultimately, with the system we have out at the launch pad, nail down where this problem is, and it's a piece part or a connector or some other element in the system that we can remove and replace and then retest and reconfigure for flight, then we're back to a baseline configuration, or we're potentially back to the same philosophy that we had before where eco sensors were concerned. That is to say, in this case, we had some specific suspect conditions with the system we have at the pad. Therefore, we implemented the 4 of 4. We might very well go back to our baseline 3 of 4 criteria if we have, in fact, positively identified and rectified the problem. Beyond that, it's speculation, but that's, again, notionally the kind of thing that we could do. Tark?
Thank you. Tarek Malcolm with Space.com and Space News, I think, for Bill. Bill, I was just curious, you mentioned that there is, I guess, a little chance of impact of running this to ground to the future flights for the space station, but can you kind of comment on the advantage of really hunting down this glitch and maybe putting it to bed for good, and how that will put you in a posture for completing the space station by 2010?
Yeah, again, I think you know, this has been kind of a cloud that's always been there over us. You know, we thought we had it fixed when we changed out the engine cutoff sensors before. We thought it was the device itself, and we've now ruled that out. We've picked the best devices we've got available and put them in the tank. So if we can determine what this problem is, we can then remove it, and then it doesn't show up at some inopportune time when we're trying to fly, and maybe we don't have as much schedule margin between the individual flights. So this can be a huge advantage to us to get this understood and move forward. And by understood, you know, there's a couple dimensions here. You know, we'd like to find what the actual problem is, but even if we can't find a problem, if we can rule out a lot of other things that it's not, then that also minimizes the trade space and then allows us to build these operational things that you were asking Leroy about. So to us, it's data is data, whether it helps us find the specific failure or it rules out all the things that it can't be causing the failure. That helps us figure out a way to build better operational rules to fly safe and continue with the manifest. So I think this will be a tremendous benefit for us to find this now.
Eileen.
Thanks. Irene Klotz with Reuters for Bill. There was quite a scramble, of course, on board the space station to get Harmony ready for this flight. Can you talk a little bit about what would be your plans now for kind of station operations? And I forgot the other part of my question.
Okay. I guess in terms of station, they'll again look at this period and see what they want to go do. I think that you may have heard on air-to-ground that they're starting to talk to the crew about potentially a stage EVA in here to do some solar array alpha joint looks. I don't think they've really officially decided that yet. They're looking at that. But we've got an opportunity now between a no earlier than shuttle flight of January 2nd. Is there some things on board station we could do to posture ourselves in a better position? So the station team will look at that and see what they need to go do and see how they can optimize and take advantage of this time. So now that we're given this time, how can we optimally use it?
Okay, Patrick Peterson with Florida Today. There was some time between the discovery of the failure of the sensor and the announcement that the mission had been scrubbed. Were you considering any other options at that time that might have allowed you to launch with 3 or 4, or looking for some rationale to do that?
I might be able to answer that one. No, as soon as I mentioned earlier, as soon as it went wet and the voltage did what it did, we had a confirmed failure, and the program had provided us with clear marching orders with the LCC. We were 4 of 4. So when that violation occurred and we confirmed that we were scrubbed as a launch team. And what we were doing were just making sure we were lined up for our troubleshooting plan and discussing it with Leroy in the program. But what we knew as a launch team that our recommendation to the program was no go. We were a clear violation of the LCC. And again, we were just setting up to get into our troubleshooting.
Okay, we'll take one more question here and then go to Johnson Space Center.
Hey, Phil Keating, Fox News. So, will you roll back or to VAB, or will you wait till Tuesday to make that decision? Are you shooting for January 2nd specifically? And what role does the manufacturer of the sensor play in getting this all resolved?
Let's see, Phil. I'll take the first part of that, and Doug can follow up. We have a lot of options in front of us before, if and when we would need to roll back. So we're going to consider the recommendations that the team brings forward on Tuesday. The Tuesday recommendations and any troubleshooting that we might do while we have the system out of the launch pad allows us the opportunity to fly as early as January 2nd. If we determine subsequently that we need to roll back and do more invasive kind of work, then that probably does not support a January 2nd. From the standpoint of the manufacturer, they have been involved all the way along for a couple of years now at least in our troubleshooting and in all the efforts really in the eco circuit, different piece parts and manufacturers thereof. So they've been very involved. And for other details on the processing, I'll defer to Doug.
Okay, well, in terms of our capabilities out at the launch pad, we've got very good access, particularly inside the orbiter aft. So there's almost limitless troubleshooting we can do there, and we couldn't do anything more in the VAB. So there's nothing there that would drive us for a rollback, and we've got very good access to the tank. So we can do extensive troubleshooting out there before we would even entertain rolling back. And again, there's not many things that we can't do out at the launch pad that we could do in the VAB. So I think that'll be our focus. And again, the test team is going to secure the pad and start gaining that access for the team. And when they start developing their troubleshooting plan and give us some work tasks to go execute, we're going to be cocked and ready and go implement those as quickly and professionally as we can.
Okay, now we'll take one question from Johnson Space Center in Houston. Go ahead, Johnson.
This is Gina Sinceri, ABC News for Bill Gerstenmaier. Bill, with 13 missions on the manifest, including Hubble, how do you think you'll finish the space station with just 2.5 years left to fly the shuttle when you're averaging 3 flights a year?
Again, if you look at this year, at the beginning of this year, we started out with the hail damage on the pad that really pushed this entire year into a very compressed time frame. And you look at the flight rate we've been flying at, essentially once a month. The team was ready to go fly again here. I think we've got easily the capability to go fly the 4 flights a year that we need to go do to accomplish the manifest, and it fits. And again, right up front here, we have enough margin in our schedule. We can take this slip into January, and it doesn't impact us. If it turns out to be a little bit further into January, then that can move the next flight a little bit, and it still doesn't impact the overall manifest. So I think when we lay it out, again, we have a very achievable schedule in front of us. The team shows that they can execute, we can work. The activity we just did on station is probably the most complicated assembly we have ever done, and all that has worked precisely the way it needs to work. The recovery from the hail damage, it was phenomenal work by the team down here at the Cape. I mean, they did an unbelievable job to get that tank ready. So I don't have any doubt that with the remaining time we can accomplish those flights. And it's not a big deal to us. If something really bad happens to us, we've got some ability to remove some of those flights at the end. But again, I think the schedule fits well, and the team is moving forward. We shouldn't look at this as a setback, and we shouldn't focus on that. We're doing exactly what we need to do to essentially complete the space station.
Okay. Any other questions, Gina?
What are you willing to give up on space station construction if you have to give something up?
Again, I'm not ready to discuss that because we're nowhere near that, but like any good ops team, we've got 6 backup plans in our hip pocket, and at the right time we'll go execute one of those backup plans.
Thank you. Irene?
Irene Klotz with Reuters. The other part of my question is about the ATV. I just was wondering what, how that fits in as the overall supplies and capabilities of station, or is it really kind of a free flyer, no pun intended, that it can just be fit into the schedule whenever it's ready to fly, as opposed to whenever the station might be ready or in need of the supplies that it's carrying? Thanks.
Yeah, in terms of ATV, it's currently scheduled for February 14th launch, which is compatible with the shuttle launch on the 14th, and we've looked at that. In terms of the cargo that the ATV is carrying, it's important cargo to us, but it's not mandatory cargo that needs to be delivered at any specific point. So in that sense, if it's delayed, deferred a little bit, or what happens to us, it's not so critical to us that it disrupts the entire sequence. So it's seen as important cargo, but not mandatory cargo to us.
Does Columbus need to be there before ATV flies?
No, there's no constraint about which vehicle needs to be there first. We can accommodate either way.
Bobby Block from the Orlando Sentinel for Doug. Since you can do so much out at the launch pad, what would be the situation which you would find that you would have to roll back to the ATB for?
At this point, I can't really even envision one. You know, we've got to see what the team comes up with and go through that whole process. So I'd really be speculating at this point to try to venture an answer for you. But again, I'll just echo it again. We really have good access and a lot of flexibility and the capability to do whatever that team asks us to go do.
Okay, any other questions here, Kennedy? One more from Marsh over here.
Marcia Dunn, AP, just to follow that, Doug, could you actually pull out a sensor at the pad if you wanted to, or do you have to roll back for that?
We have different views on that. We have changed the sensors out at the pad, I've been told. That was quite some time ago. You've got to build enclosures and the foaming and all. I don't think that we have currently a certified method of taking the foam off, getting the panel out, getting the sensors on, and then redoing respraying the foam. That's not saying that we couldn't to do that in the vertical. I'm not saying we couldn't get there, but that would really be a challenge. But everything thus far points to the fact that it may not be, that it's not the sensor. So that's something that's probably remote. And if we were faced with that, we still have some work to do to see whether we could actually pull it off at the pad.
We're just going to take a couple more questions. Bill?
I'm Bill. Sorry. I'm sorry. This is a question that there's not an answer to as well. It's just pure speculation. But I mean, just trying to get a sense of how you guys think about this. If you, Doug, I know access is good, but there's some places you can't get to at the pad. The monoball, I guess, or that connection between the orbiter and the tank. If with your troubleshooting you isolated this problem to a place where you can't get to, is isolating it enough to deal with flight rules that would let you go fly without having a sensor, if you see what I'm saying? If you knew where it was and thus the health of the others on the circuit. Thanks.
Well, let me take the first part of that, and then it's really a programmatic answer. We do have access up to the monoballs off of the orbiter weather protection. So from our initial assessments, we can get to that feed-through connector. So that is work we could do out at the launch pad. And as a matter of fact, we've got schedules and plans to go do that if we're asked to go do that by this team. So as I said, the access is good. Now, in terms of flight rationale, I'll gladly hand that over to my ops manager and let him field that one.
Of course, Bill, it would depend on what we find, as you know. And so I can imagine cases where if we were able to positively identify the cause and predict the repeatability of it some way, and or prevent or rectify it at least partially, then we could talk about operational workarounds. If it was just a matter of identifying it and then not being able to in any way control, predict, or otherwise be able to count on the response, then we'd have to talk more about whether or not there's something we could operationally work around. So I can imagine other scenarios as well. So as you said, it is speculation, and but certainly there's a possibility that it could be a scenario like that.
Okay, Mark, and then Holly, and then let's wrap up.
Thanks. I think this is for Leroy. What happens with the Atlantis crew at this point? Do they get to break from quarantine, return to Houston? And if they do you envision that they would do any training with the control team on using this additional instrumentation that you've developed over the last 2 flights to kind of sharpen the communication between the use of that if you needed it in the future?
Well, let's see, Mark. The crew will certainly come out of quarantine and go back to Houston, and they will do some refresher training since we're essentially out of the December launch period. And they'll spend some time with their families, of course, and then get back into a sort of a refresher training template. As part of that, they will do training with the Ascent Flight Control team, and they'll do their normal suite of simulations for this kind of scenario where we're down for some period of time, a couple of weeks or a month or whatever the case might be. As part of that, I have no doubt that the simulation supervisors and the other folks that put together those training scenarios will include some of those kinds of cases, and that'll be whether or not we have determined a need for it from a programmatic standpoint. But knowing how they operate, they're very thorough, and they'll want to cover the waterfront with the possibility of scenarios that we might ask them to be able to manage for us in real time. So I would suspect that's a real possibility.
Mark, actually, Holly Hickman, Fox News Radio. Mark asked my question, but in terms of tanking tests, I know Wayne Hale said that you had 13 cycles you could put this tank through. Would you, if you don't have enough data that you're satisfied with from today, would you consider another tanking test before launch?
Sure. Yeah, we haven't taken anything off the table at this point. We're just starting to put things on the table, and certainly a tanking test is one of the things I expect to be in the suite of things that we'll consider. Again, recommendations to come forward to the program starting Tuesday. Tanking test is certainly a real possibility and a probability.
Okay, if there are no other questions, that concludes today's news conference. For more information on Space Shuttle Atlantis' launch and updates, please visit www.nasa.gov/shuttle. Thank you for joining us.
21 sollte die Raumfähre heute Abend abheben, aber daraus wird nichts. Die Atlantis wird frühestens im Januar starten. Grund für den verschobenen Flug ins All sind erneut Probleme mit den Tankuhren. Funktionieren die Steuerungselemente nicht richtig, können sie eine Explosion auslösen. Das Shuttle sollte eigentlich das europäische Forschungslabor Columbus zur internationalen Raumstation ISS bringen. Mit an Bord wäre auch der deutsche Physiker Hans Schlegel gewesen. Nun muss er sich weiter gedulden.
Deutscher Astronaut Hans Schlegel wird dieses Jahr nicht mehr ins All fliegen. Die US-Raumfahrtbehörde NASA hat den für heute Abend geplanten Start der Raumfähre Atlantis erneut verschoben. Nun soll am 2. Januar ein neuer Versuch unternommen werden. Grund für die Verzögerung ist ein defekter Sensor im Außentank der Raumfähre. Ursprünglich sollte die Atlantis schon am Donnerstag ins All fliegen. Seitdem war der Starttermin wegen der Sensorprobleme immer wieder verschoben worden.
Nach 3 Verschiebungen wegen technischer Probleme wird die US-Raumfähre dieses Jahr auf keinen Fall mehr ins All fliegen. Die US-Raumfahrtbehörde NASA sagte den für heute Abend angekündigten Start wegen einer fehlerhaften Tankanzeige ab. Schlimmstenfalls könnte ein solcher Defekt zur Explosion der Raumfähre führen. Frühestens Anfang Januar plant die NASA nun einen neuen Startversuch.
Hallo, Carsten, der Start ist abgesagt zum wiederholten Mal. Man könnte eigentlich noch bis Mitte nächster Woche starten, will aber erst im Januar nun ins All abheben. Woran liegt's?
Ja, letztendlich, man will wohl auf Nummer sicher gehen. Das Problem mit den Tanksensoren ist ja nicht neu. Das haben wir eigentlich schon seit Donnerstag. Und kurz nochmal gesagt, das sind ja nicht nur einfache Anzeigen, die Auskunft geben über die Füllmenge des Tankes, sondern diese Sensoren sind verbunden mit dem Bordcomputersystem und die melden dann eben, wenn der Sprit vorbei ist, so, dass das Triebwerk automatisch abgeschaltet werden und die Tanks abgesprengt werden können. Also eine ganz wichtige Sache bei einem Flug ins All. Und die NASA will jetzt kein Risiko eingehen, sondern sie will genau untersuchen, an was es gelegen hat und diesen Fehler natürlich abstellen. Man war optimistisch, heute starten zu können. Es hat nicht geklappt, aber man hofft natürlich jetzt durch diese erneuten Fehlermeldungen weitere Daten gewonnen zu haben, so dass die Ingenieure diesem Problem dann endgültig auf den Grund gehen können.
Wenn man sich die Entwicklung dieses Problems anguckt seit Donnerstag, Carsten, gewinnt man den Eindruck, als wenn es zwischen NASA und ESA, also der Europäischen Raumfahrtbehörde, zu einer Divergenz, will ich mal vorsichtig ausdrücken, gekommen ist. Denn die Amerikaner haben gesagt, glaube ich am Freitag war es, eigentlich kann man ja auch mit den Dingern starten, wenn sie nicht richtig funktionieren. Klappt die Zusammenarbeit?
Ja, also die ESA ist natürlich in dem Falle mehr oder weniger Kunde. Es ist natürlich so, dass dieses Columbus-Modul, das sozusagen Aushängeschild, das Flaggschiff der europäischen, der deutschen Raumfahrt, das kann nur vom Shuttle ins All gebracht werden. Und die letztendliche Verantwortung, die tragen natürlich die Manager, die Flugmanager der NASA. Und die müssen eben abwägen, sie müssen entscheiden, inwieweit dieser Flug als sicher anzunehmen ist oder nicht. Und das ist eine Entscheidung, auf die die ESA nicht so direkt Einfluss nehmen kann. Das obliegt dann dem Flugbetreiber. Und das ist ganz klar in diesem Falle einzig und allein die NASA.
Ja, herzlichen Dank, Carsten Lüb in Oberpfaffenhofen.
Enttäuschung für die europäische Raumfahrt. Die NASA hat den für heute Abend geplanten Start der Raumfähre Atlantis erneut abgebrochen. Grund waren, wie schon bei den beiden vorangegangenen Anläufen in dieser Woche, defekte Sensoren in den Treibstofftanks. Frühestens im Januar wird es einen neuen Startversuch geben. Damit verzögert sich auch der Einsatz des deutschen Astronauten Hans Schlegel. Er soll mit der Atlantis zur internationalen Raumstation ISS fliegen und dort das europäische Labor Columbus installieren.
Anfang Januar ins All aufbrechen. Das teilte die US-Raumfahrtbehörde NASA mit, nachdem es vor einem erneuten Startversuch wieder Probleme mit einem Tanksensor gegeben hatte. Die Atlantis soll das europäische Weltraumlabor Columbus zur internationalen Raumstation ISS bringen. Zur Besatzung gehört auch der deutsche Astronaut Hans Schlegel.
Kurz vor Sonnenaufgang stellten die NASA-Ingenieure beim Betanken des Shuttle das bekannte Problem erneut fest. Einer der Sensoren im Haupttank der Atlantis funktionierte nicht. Der entscheidende Moment. Hier ist die Bodenkontrolle. Sensor Nummer 3 hat gerade versagt. Das sind keine guten Nachrichten. Unser Team ist natürlich enttäuscht. Wir können jetzt frühestens Anfang Januar starten. Wir hoffen, dass wir den Fehler schnell finden. Wir geben unser Bestes, damit wir das Shuttle bald wieder startklar haben. Das Problem war bereits beim ersten Startversuch am Donnerstag aufgetreten. Ohne die Sensoren könnten die Triebwerke des Shuttle im Falle von Treibstoffmangel am Ende der Startphase nicht rechtzeitig abgeschaltet werden. Das könnte das Shuttle zerstören und die Besatzung gefährden. Mit der Atlantis soll das europäische Forschungsmodul Columbus ins All gebracht werden. Das knapp 1 Milliarde Euro teure Labor ist eine europäische Gemeinschaftsproduktion. Der deutsche ESA-Astronaut Hans Schlegel soll das Modul an die internationale Raumstation montieren. Die NASA gibt sich optimistisch, dass der Ausbau der internationalen Raumstation trotz des Rückschlags wie geplant weitergehen kann. Für Europa aber bedeutet der Startaufschub eine erneute Enttäuschung. Das Columbus-Forschungslabor sollte bereits vor Jahren an Bord eines Shuttle ins All gebracht werden.
NASA. Die Probleme mit den Treibstoffsensoren der Atlantis sind offenbar so gravierend, dass der Start nun auf frühestens Anfang Januar verschoben wurde. Unter den Besatzungsmitgliedern ist auch der Deutsche Hans Schlegel, der das europäische Forschungslabor Columbus an der Raumstation ISS installieren soll.
Well, good afternoon, everybody. Welcome to the NASA's Johnson Space Center. Joining me is Wayne Hale, who is the Space Shuttle Program Manager. He's here to update you on some of the data that came out of today's tanking test of Space Shuttle Atlantis out at Launch Complex 39A. And with that, he'll have some opening comments, and then we'll take questions, of course. And with that, I'll turn it over to Wayne.
Thanks, Kyle. As you know, today we provided a tanking test with instrumentation, special instrumentation on board Space Shuttle Atlantis to look at the wiring on our liquid hydrogen fuel low-level sensor circuits. And we gained quite a bit of data today, I'm very happy to say. I think I can confess to you now that I was really quite worried that everything would work perfectly and we wouldn't be able to find where our problem lies. And fortunately, it sounds interesting to say it, but fortunately things didn't work right today. And so we were able to capture the data, and I think that will set us on the right path to fix our problem so that we can return this important safety system to operational capability and fly again in the near future. Today, what we saw actually were 3 separate problems. You know, there are 5 sensors, 5 level sensors in the bottom of the liquid hydrogen tank. 4 of them are the engine cutoff sensors, all at 1 level, and a 5th sensor which is located at the 5% remaining level, slightly higher in the tank. And today we had problems on 3 of those sensors, and we captured the data. I'm sorry, we had problems on 3 of those sensors, and we've captured the data, and the data is indicating that we have a problem at what we call the feed-through connector that leads the wires from the inside of the liquid hydrogen tank and the cryogenic fluid to the exterior of the tank. That's a multi-part connector, and our time domain reflectometry instrumentation has indicated that is where our open circuits are occurring at these very cold temperatures. And so we're going to concentrate our efforts to understand what we can do to fix that and go fly again. Today we actually had 3 sensors, as I said, fail. We had the eco sensors 2 and 3 fail open circuit very briefly, shortly after we went into fast fill for 2 or 4 seconds each. Sensor number 2 remained fine for the rest of the test. Sensor number 3, I'll talk about a little bit more, indicated problems when we started to drain the tank, but operated properly for most of the test. Sensor number 1, shortly after 2 and 3 had their episode, sensor 1 indicated an open circuit, and it is the one that we did most of the troubleshooting on. It remained open circuit until well after detanking, well after the liquid level had dropped below the sensors and the tank was physically dry. And that sensor and all the sensors have returned to reading properly now. Sensor number 3, about 4 hours and 5 hours into the test, failed again, open circuit, and that was after the red crew had been out. So some of that data is still being collected. Now the team is looking at all of this data that they saw today, all of the recorded voltages, this TDR instrumentation. There is literally gigabytes worth of data that was collected today. They'll be going over this data very carefully for the next few days, trying to make sure they properly interpret the results. The preliminary indication is that we have a problem at this connector. And a connector, as you know, is a multi-part element. There are a central part called the pass-through, which has got pins that go literally through a vitreous glass member. And on either side, then you have the socket connections, both on the inside and on the outside, that made up with those pins. The only sensors or signals that go through this connector are the 5 sensors I've described. Now, between the 3 times that we have tanked this vehicle, we've seen all 5 of those sensors misbehave in one way or the other. The only common point where all the wires come together is that pass-through connector. So we're going to be taking a very hard look at how it was assembled, what in particular might be going on with this connector, how we might find or manufacture better connectors, and what we might do to repair. Forward work that we have ahead of us. I left the team post-test teleconference just a few minutes ago. It's still going on. The plan tomorrow is that they're going to come in and talk to program management in a formal way with some recommendations for forward work. Surely there will be some more troubleshooting. There are a number of options that the team may potentially recommend in terms of equipment replacement. But we're going to take this in a very systematic way. We want to make sure that at the end of our episode we have a good circuit in all 5 of these circuits, because they're all important to us, and that we have a good, safe vehicle to go fly. So we want to take the opportunity while we've got this failure, which has been intermittent, to make sure we know how to solve it. One of the things I'd like to say, maybe, at the end of the day, is that we probably owe an apology to the folks that make the little sensors. We've talked about swage connections down there at the level sensors for a couple of years now, and have worked very hard at the factory to eliminate that as a possibility. And today, the sensors themselves were exonerated in this test, and this is clearly a problem in the wiring upstream as it comes out of the tank. So we'll be concentrating our efforts there. I do not have any information about a launch date today. Frankly, we are still in the midst of troubleshooting. As you know, we put a memo out that instructed people that they should think about a launch date no earlier than January 10th. And where the troubleshooting and replacement and repair work leads us will determine what the launch date's going to be. We are not going to be driven by schedule on this one. We need to get to the bottom of this, fix it, and make sure it's fixed once and for all, and then we can fly safely for the rest of the program, at least in this area. And so with that, I will stop and take questions.
Okay, we'll start with Mark here and then go down to the Kennedy Space Center for questions. Go ahead, Mark.
Hey, thank you. It's Mark Carreau from the Houston Chronicle. Can you talk a little bit about the age of this equipment and whether your experts believe that might be a factor, whether it's cold temperatures, if it's something to do with the manufacturing, and maybe just touch on the availability of, I don't know whether this is custom hardware or something you can go buy somewhere else. How do you deal with manufacturing something better?
Those are all good questions, Mark. We have been very concerned about aging. This equipment is all less than 10 years old, which is pretty new by shuttle standards. So we don't believe there are aging concerns, but we certainly have a team running down those possibilities. Let's see, we have everything on the shuttle, I think, is custom made, so I don't know we can go out and buy anything off the shelf. We certainly know who the manufacturer of this equipment is and can procure new connectors, and I don't have a timeline on that. There are certain things that we might do to existing connectors that we have, or feed-through connectors that we have in the inventory, that might make them more robust. And I have to say that part of this may just be an installation problem. We went to great lengths to really seal these connectors up tight. And some of the theories have to do with the fact that we pull, as you get cold temperatures, a slight vacuum in the system because it's sealed so tightly, and that may in fact cause some of these open circuits as pins and sockets move in response to this partial vacuum. So we have quite a bit of data in the sense that we know that this connector area is what we need to concentrate on, but we are not at the bottom of it to tell you exactly what we need to do, nor in fact exactly what is going on in that connector. So we have a bit more work ahead of us. But I would tell you that these sorts of problems and these sorts of components are not long-term problems in the sense that a manufacturer of these components can be turned around in fairly short order.
And I'd like to follow just with probably kind of a question of clarification by what people mean by an open circuit. As I sort of followed this, you know, I've come to believe it's somewhere where you're not getting a contact in the system that's transient or momentary, and I'm wondering if what you're kind of saying now is that in this connector that may be the source, or the place, I'm sorry, where you're losing conductivity for brief periods of time or hours at a time?
Well, yes to all of the above. And some of these circuits we've lost conductivity for brief periods of time, 2 to 4 seconds today on a couple of them, and in other parts of the circuit we lose it for hours at a time, and it is associated with the cryogenic temperatures. These things are not showing up at normal everyday room temperature when the tank warms back up and is empty. So we know that there's something going on that's temperature related that makes the circuit open up, and just like your light bulb, when the wires aren't connected, the light bulb doesn't light. These things don't work unless they've got a complete circuit.
Okay, let's go to the Kennedy Space Center down in Florida for questions there.
Yes, Marcia Dunn of the Associated Press. Wayne, I'm wondering if this connector is physically located outside or inside the tank and how you might go about accessing it.
Well, by the nature of it, it goes through the wall of the tank. So part of it's inside and part of it's outside, and that's kind of why we call it a pass-through connector, Marcia. It can be accessed, most of it, from the outside. And in fact, some timelines have been developed to change out those parts that can be changed, that can be reached from the outside, and they are on the order of a week or 10 days kind of work to do that change out. However, the part that's difficult to get to is the socket connector on the inside of the tank, and that would be more invasive, and you would have to go inside the tank through the manhole cover that we've got at the bottom or some other access point, and that obviously would be a longer-term operation. So exactly what we've got to do and where in this three-part connector we have to do it is a little bit of work ahead of us. I'm just pleased as punch that we know it's in the connector and not some other place in this 100 feet or so of wiring and sensors and electronic boxes. So we know what area to concentrate our efforts.
And how big exactly is this connector? If not the dimensions, what's it resemble in size?
Well, let's see. I don't have the dimensions at hand, but if you think about a big electrical plug like you might see in industrial lighting or perhaps the sort of lights that you have in a television studio, one of those big, about 1.5 inches in diameter and maybe 4 inches long connector. Again, it's made up of at least 3 parts. I mean, there's a lot of little parts, but 3 major parts. The sockets that connect to the wires on the inside, the sockets on the outside that connect to the wires that lead away from the tank, and then the pass-through part, which is this metal, glass, and pin arrangement that I described earlier.
Patrick Peterson with Florida Today. Do you intend to make this repair at the pad, or do you are still holding open the possibility of rolling back? And also, do you believe that this is a new phenomenon, or do you believe this is what might have caused the earlier failures that delayed launches several launches ago?
Reminded of the great Mark Twain quotation, I knew the answer and I was pleased to supply it rapidly. I don't know. Answer to either one of those.
All right, well, this is Bill Harwood. Let me ask you another question you might not know the answer to. It's just about the retest options for this. I'm just curious if at this point you're thinking another cryo test at some point will be required, or do you think you can get to a point where you can get comfortable with this and make your launch attempt a fueling test, if you will? And I'm wondering if given what happened today with sensors 1 and 3, or which one was it that didn't fail earlier? I can't remember. Are you still optimistic about getting to your 3 out of 4 criteria for launch, and how that plays into all this?
Wow. We have stood down from a near-term retanking of the vehicle. In other words, we had plans to come back in another 24, 48 hours and do another tanking if we had suffered some failures with the instrumentation or something not really related to the eco sensors. That did not occur. We got a good test. We got the information we wanted to get. So we have stood down from a near-term tanking test on the vehicle. Whether or not we think about this for 48 hours and want to come back at some point and do another tanking test, I think is work ahead of us. I will tell you that there are cryogenic tests going on off the vehicle as we speak. We built up the whole set of cables, connectors, harnesses, sensors, and the box, and then we have a couple of sets of that, both at the Marshall Space Flight Center and at the Kennedy Space Flight Center, where they are undergoing cryogenic temperature testing on what we call a bench test, not on the vehicle. So we have those kind of tests ongoing, and they will continue. And we'd like to get to the bottom of this. I suspect part of the way we'll get to the bottom of this will be to very carefully take apart what we've got on the vehicle, take a really close look at how it's assembled, any witness marks, cracks, voids in the soft goods that might have occurred. And part of the data will come from these bench tests, and then we will decide how to go forward from that point. So whether or not there is another tanking test in our future, long term I don't know. Short term we are not going to do one this week.
Bobby Block from the Orlando Sentinel. I guess it's a variation of what Bill was asking. Is there a way, if you arrive at a fix, to figure out how it works without doing another tanking test?
Well, you know, you're off into the hypothetical here, and of course the answer to most hypothetical questions is yes, it's possible. What I need for the team to do, they have been on station all day. They are in fact standing by, continuing to watch as the temperatures continue to rise, as the tank dries out and returns to ambient temperature. There may be more interesting data together before the end of the day. I want them to go home and think about it. We're going to come back tomorrow and talk about our options. We probably will not make any really hard and fast decisions tomorrow at the program management review. But we certainly will hear the status and the best thinking of the team, listen to their recommendations for a go-forward plan, and there will be more tests in the future. I would like to fly as soon as practical, but more than that, we need to fix this problem, and so we're not being driven by any particular date on the calendar as a launch date. What we're being driven by is the technical data. And my point in coming over here today was to give you folks a kind of a dollop of the data that we got today and what our thinking is, and when we make some decisions as to the forward plan, which will be in a day or 2 or 3, I'll be more than happy to come back and tell you what we've decided to do. Until then, there is a lot of brainstorming, a lot of back and forth discussions, email, phone call, face-to-face meetings that are going to take place over the next couple of days while the engineering team grapples with what is the best way to proceed forward. The really good thing is we know exactly what we've got to work on now, which is that set of connectors. through the liquid hydrogen tank wall, and we can concentrate our efforts there, and that is a problem that's solvable. And whether it takes a couple of days or a couple of weeks or a month, I don't know yet, but I am confident that the team, now that we're focused on it, can come to a good solution and put good hardware on the vehicle, and we can go fly with this system operational as we'd like for it to be.
Thanks. And just one more question. You mentioned the fact that it could be an installation problem. Could you tell us a little bit about where those parts are installed? Are they done here at KSC or at Michoud when the tank is made?
This connector is put together out at New Orleans and at the Michoud assembly facility. And let me hasten to say that is a leg on the fault tree. We don't know that there's anything improper in the installation. What we do know is that we have tried to make improvements in how we install this connector, and it may be, as we sometimes find out, when we try to make improvements, we change things in ways that have unanticipated consequences, and we may have in some way made it worse. Now, I don't know that that is the case. What we need to do is go do the dissection, the removal, the investigative work to find out what exactly is the contributing factor at this connector that caused these sorts of problems to start happening as we return to flight, and we didn't see before. So something has changed, and we need to still keep plugging to find the root cause and fix it.
Hey, Wayne, it's Bill Harwood again. I just wanted to follow up on part of the original question, which was there anything in the data that you've seen to date that would influence the rationale for wanting 404 for launch or 304 or any of that? Or are you back to square one in terms of the LCC and trying to see how you go forward? I realize you hadn't gone through that yet, but just kind of what your thinking is at this point. Thanks.
Bill, I got to tell you, that's kind of putting the cart before the horse. We need to go fix this problem. We need to do our very level best to make sure it doesn't happen again, and then depending on how good we feel about that fix, we'll come back and address what the launch commit criteria is going to be. So we need to keep our priorities in the right order. We've narrowed this down. We made a great stride today in narrowing this down to this feed-through connector. We need to go figure out what's going on in the feed-through connector and do what we need to do to make sure that it works properly and that we keep good continuity as we tank the vehicle and as it flies, and then we will sit back and think about what the launch commit criteria ought to be. Again, we like to do that in the proper order so that we know what we're dealing with, because there are different things that you might do if you didn't feel very confident that we'd gotten a good fix. You might want to require more of them to be working at launch than you really need. On the other hand, if you felt like you had gotten a really good solution and a high confidence, you'd be willing to go back to the old LCC at 304 or maybe something different. I don't know, but let us work this in the proper order, and we'll come back and talk about launch committed another day.
This is Marcia Dunn, Wayne, with one more problem. You mentioned that you wanted to, you would like to fly as soon as practical, and I'm wondering if it's practical to think that this problem can be fixed in time for a January 10 launch attempt.
I'll try one more time. The program has been asked to assemble the International Space Station. We would like to do that as promptly and efficiently as we possibly can, consistent with safety and good engineering practice. So when I said I'd like to fly as soon as practical, that's really a shorthand way of saying that. We don't need to go fly if it's not safe. I don't intend to fly if we're taking a great risk that we shouldn't take. What we're going to do is we're going to follow this trail where it leads us, and we're going to solve this problem, and then we'll go fly. And whether it's January 10th or February 10th or March 10th, we will make the program fly out our mission and get the space station assembled before we need to retire the orbiters, and I'm not worried about that. What we need to do is take it one step at a time and make sure we get this right now.
Mark, we can finish up from here.
Mark wrote the Houston Chronicle. I had a couple questions. Did the time domain reflectometer pulse generator, is that sort of the device today that helped you get to the location of the problem, and could you maybe explain how that led you there in a small amount of detail? And then I had a follow-up question.
Okay, well, we need to get the technical experts up here because I get lost in electronics talk pretty quick. But the way I understand this is this basically sends out a very short electrical pulse down the line, and it measures impedance that gets reflected. Impedance, you know, is like resistance, but it's got an imaginary part. And if you are an electrical engineer, I'm not. So it sends a pulse down the line, and based on when the reflection comes back, it tells you where the resistance in the line changes. And if you want the real technical experts to come in, we can give you chapter and verse. But the short answer is it sends out a series of very short, high-frequency electrical pulses and looks at the reflection that come back down the line. And based on the time, then it knows how far down the wire you have your open circuit. And that all lined up to the connector. Unfortunately, the resolution is not quite good enough to tell you where exactly in the connector. I'd kind of like to know inside part or outside part. But we know it's in that connector, and we don't really know whether it's inside part or outside part.
Thanks. And just one follow-up from me. You mentioned these kinds of parts are on the order of a decade or so. So I guess I'm just looking for some clarification. I suppose these are made in lots, and then you keep them until you use them, and these pieces go away with the tank when the shuttle's launched. You don't recover them, as it were, to reuse or reinspect in any way.
Yeah, you know, the external tank suffers from being the only part of the shuttle that we don't get back. Every other part we get back, and we tear it down and examine the minute details and every piece part and every indication and every streak and smudge, and I think that contributes a lot to safety. If you look at Space Shuttle main engines, for example, very high-performing piece of equipment and a lot of risk in big rocket engines like that. And part of the reason we've been so safe over the years with the main engines is that we get them back and we can literally tear them down and look at all the little piece parts and see how they performed. The external tank, you don't get back any of it, none, zero. And so all you got is the data that came down on the telemetry stream, whatever pictures of the outside, you know, you got back, whether from ground cameras or in flight. So we have to make a lot of inferences on what happens in the tank. It would have been really nice sometimes to get a tank back and see what had gone on inside that tank, but we don't. And so we probably have been chasing some rabbit trails because we couldn't get a spent piece back to take apart. Now we have got a different way of looking inside this tank, at least electrically, and we have got some more information, and that's been very helpful, very helpful. My hat is really off to the team that put this whole troubleshooting process together.
Okay, I think that's all the questions we have, and as Wayne alluded to, we will keep you updated on the progress of the troubleshooting efforts and come back when it's appropriate and we're able to do so to give you an update. Until then, follow all the activities of the Space Shuttle program through our website. You see it there on your screen, www.nasa.gov/shuttle. And as usual, we'll be back with our space station daily coverage, so look forward to that tomorrow at 10 Central, 11 Eastern. Thanks for coming.